Hello, 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 hi. Good morning, everyone. Thank you very much for coming to this talk. And I wanted to introduce myself. Hi, I'm Ellen. I work for Apollo GraphQL on their iOS SDK. But I am not here to talk about GraphQL today, other than to wear this shirt so that after this talk you think, I suddenly want to implement GraphQL, and I don't know why. Anyway, I've been doing both iOS and Android development for the last decade. And one thing that's annoyed me the whole time is the amount of time you need to duplicate the work that you've been doing on one platform onto the other platform. And this isn't a new frustration. People have been complaining about this for eons, not just between iOS and Android, but between tons of other platforms as well. In fact, not wanting to repeat yourself is one of the major motivators for wanting to use a cross-platform framework in the first place. Both engineers and managers see a benefit to not having to do work twice. Engineers from a perspective of not having to hunt down the same bug multiple times, and managers from the standpoint of not having to pay for the same work multiple times. So there have been approximately 1 gazillion attempts to solve this problem, all of which have had their pluses and their minuses. And you often hear way more about the minuses, because any native iOS or Android developer who's been doing this for a while has a horror story about cross-platform. And a number of large companies have written and talked in great detail about their experiences working with cross-platform. Earlier this year, Airbnb wrote up a bunch of their experiences trying to use React Native. And one of the things they talked about extensively as a problem was that React Native sometimes made things that would be trivial to do on a per-platform basis unnecessarily difficult. They also talked about how much more difficult root cause analysis became when trying to troubleshoot with React Native, because of the number of ways and places in which things could go wrong. Now, this part very much lined up with my own personal experience working with other JavaScript-based cross-platform frameworks. Now, I don't know JavaScript very well, and I really don't work much with untyped languages, so working with JavaScript makes me bananas. I fully acknowledge that this is my problem and not JavaScript's. However, because it is not a language that is natively used by either iOS or Android, it means that in order to debug something really weird, you need a developer who understands iOS, a developer who understands Android, and at least sometimes you need someone who understands the various languages involved in iOS and Android. And then you need a developer who understands JavaScript so they could help figure out if there was some weird JS issue. And then you needed someone who had some kind of understanding of how the cross-platform framework you were using talked to all the other elements. And if you wanted all of that to be one person, well, good luck with that. You'd generally need at least 2 people to debug any major problem, and it would grind everything to a screeching halt. So I could definitely understand why Airbnb decided to reevaluate. On the other hand, DROPBOX had been well known for years for having a huge chunk of their app written in C++, and it seemed like it was actually working fairly well for them. So I was somewhat surprised when they announced recently that they were dropping it in favor of native code for each platform. I was less surprised when I read in their blog post that much of their code base actually wasn't in C++, and that their custom C++ stack had made it both very difficult to train existing developers and also to hire or retain mobile developers who didn't want to work in C++ and prefer to work in more modern mobile development languages. And the thing I took away from DROPBOX's post in particular, but also somewhat from Airbnb's post, was that when you're building something cross-platform, putting developer experience on the back burner opens you up to some serious risk. Your developers have to be enthusiastic about using a cross-platform framework to even consider using all the known drawbacks. But particularly, if you have developers who have worked in more type-safe, null-safe languages, they often refuse to go back to hunting down weird runtime pointer issues or type problems which could easily be caught by a more sophisticated compiler at build time. So when JetBrains announced Kotlin native a couple of years ago, I've been cautiously optimistic because Kotlin is type and null safe. It also has a lot of other great features that you've basically spent the last 2 days hearing about, so I won't rehash them all here. This also had the potential to solve the I don't know and potentially really don't like this language problem. for me, because I love Kotlin. In fact, I love it so much, and I have to give a very shameless plug alert here. I wrote part of a book about it, now available from raywenderlich.com. I'm also going to be giving away a copy to people who ask interesting questions in the Q&A period. Also, I have a copy of a book called Living by the Code, because why not 2 books? Anyway, Kotlin native, the idea is that you still may have the person who understands iOS, the person who understands Android, and the overlap to understanding the languages on both platforms. But then the person who understands the platform has a way better shot of having a bunch of overlap here. I was particularly excited because I thought the person who would fit into that little bubble could be me, because I've worked on both platforms for a decade. I have been rambling on and on about developing for mobile platforms since my very first webinar in 2013, in which I spent an hour talking to the void about building for both platforms. And this gets to another reason I was so excited about Kotlin native, because even then, I was telling people that the first rule of cross-platform UI, other than apparently to use as many shiny gradients as possible because it was 2013, is that iOS is not Android. Even then, I was sick of getting Photoshop documents labeled iOS and Android, which had identical contents beyond the frame around the UI. It has always driven me totally insane to see iOS UI on Android, mostly because designers were too rushed or too in their own heads to understand that the systems had some pretty fundamental differences when it comes to user interaction. And while even now there are still new frameworks being introduced, which, while trying to preserve platform conventions to the extent possible, try to focus making your UI as write once, run anywhere as possible. I really loved that Kotlin native was instead squarely focused on sharing the business logic that runs your application, not anything around how to display the results of that logic, at least directly. And having all of this in one place meant it would be easier to centralize the testing of the mission-critical parts of an application. After all, if you only have to build and test something once, the odds it's going to break in some totally unexpected way on both platforms are pretty low, and you can focus your debugging on things that are way more likely sources of problems. It also seemed like, although it might take some work to get set up properly and get started wholeheartedly, once everything was set up, I could take the expectations that everyone used to have and just absolutely blow past them in terms of speed. But I also knew from reading DROPBOX and Airbnb's posts that despite that speed, I could occasionally run into some serious blockers. And we'll get back to some of those in a bit. Because despite those blockers, the prospect of sharing logic between iOS and Android, potentially even with the server and a website, was really intriguing. So I was really excited to get started with Kotlin native, although let's be real, I've never been as good a dancer as this emoji. I'm a little bit more like Elaine from Seinfeld trying to dance. But regardless, I was still very excited about Kotlin native. I wanted to use it everywhere. And I'd been inspired to create a project called PORCH Pirate Protector at my old job at Bakken & Beck. And if you're interested in seeing some of the code that's behind all of these examples, you can go to this lovely GitHub URL. This project was essentially an idea for a giant box that you could bolt to your porch to prevent thieves from running off with packages that had been delivered from various online shopping services, and a lock that you could control remotely via a smartphone app that you could lock and unlock the box based on whether a legitimate delivery person was actually trying to drop off a package or some rando just wanted to see if there was an iPhone in that package that got left on your doorstep without a signature. And I'd settled on Kotlin native because I knew that I wanted to build an iOS and an Android app to operate it. And then I also needed to build a server to handle authentication and sending commands directly to whatever was handling the lock, which I ultimately decided should probably be a Raspberry Pi attached to a servo motor, so turning the servo would actually unlock the lock. And after I picked these technologies, I tried to verify that they all worked with Kotlin, and the answer was yes, across the board. Between both Kotlin for the JVM and Kotlin native, all of these things could be written in Kotlin. Although I have to admit my time has gotten away from me a little bit, and it turns out that hardware development is a lot harder than software development, so I'm hoping to get the hardware part of this up and running sometime early next year. But I was still able to build the iOS, Android app, and server, and it's working really nicely with Kotlin native to handle both determining what theoretical devices a user has locally and then also updating the theoretical lock state of those devices. And I learned a ton of stuff from building this application, and I want to talk a little bit about the architecture. Now, the MVA architecture I selected for this, with A, of course, standing for anything other than a model or a view for the love of God, was Model View Presenter. So I'd seen this used successfully in a couple of apps before, and it seemed like a reasonable way to separate concerns in a way that would work fairly well with Kotlin native. In fact, part of the reason I selected this architecture was that the KotlinConf app that serves as an excellent open source example of how to use Kotlin multi-platform and Kotlin native was using MVP for its architecture. At least it was until about 2 days ago when the updates for this year's app got pushed. I also thought MVP made a certain amount of sense because each of the types in MVP mapped pretty nicely onto something in Kotlin. A model could just be a simple data class, a view could be set up as an interface, and a presenter could be set up as a pure Kotlin class, which could handle business logic from anywhere. And what particularly made this stand out to me as a potentially good idea was the thought that you could set up the view as an interface, because that really accurately represented the fact that the final implementation of the view was going to be very different per platform. On iOS, it was going to be a view controller. On Android, it would be a fragment, or if you're one of those people who deeply hate fragments, you could make it an activity or a view model. And then for testing, it didn't even need to have any UI implementation, which made it much, much faster to test. So this all seemed to make perfect sense to me, at least until I went to implement it. So I wanted to talk a little bit about what this wound up looking like in practice under the hood for the detail view for a particular device that you could lock and unlock, and something really dumb that I did in my setup. So I had a presenter that lived in the common main source set and took the view, the device being displayed secure storage that handled accessing the keychain as parameters. Then I had that view interface that I discussed earlier, and this gets manipulated by the presenter. And then that interface was implemented by a fragment in the Android application. And if you're paying close attention, you can already tell that I've done something very wrong here, and no, Jake, it is not that I'm using a fragment. Who can see the problem? It starts here, where the view hangs onto the presenter, then passes itself as a parameter to the presenter, which, as you'll recall, also hangs onto the view since it's passed in as a property parameter. And when you have a view and a presenter, and the presenter hangs onto the view, and the view hangs onto the presenter, you have yourself a very classic retained cycle. Particularly in Kotlin native, this is a problem because it uses something very similar to automatic reference counting, and that prevents either reference from being deallocated. And in the great scheme of things, this is not horrendous, particularly for such a lightweight app, but it sort of broke my thoughts about what I wanted the presenter to do because of how I'd seen MVP used initially. And so I did some rethinking, and I wound up tweaking this to something I'm completely making up called MVSP, which stands for Model View State Presenter. And maybe I'm just using MVP better in theory, but it really helped me to think of a view not as a live object I could manipulate from the presenter, but as a single object which could be repeatedly returned from the presenter. Calling this a view state object seemed like a better way of capturing this to me because it made it clear that it was the way that the view should be laid out at one particular point in time. So I wound up deleting all of my interfaces and using nested data classes, which had some very basic information about how the current state of the view should be displayed. And instead of having the presenter manipulate the view directly when methods were called on it, I changed up the methods that were called when the user wanted to perform an action to take a lambda to update view state when an async operation kicked off, and then ultimately return another view state which the fragment could then display. Data always went from the fragment or view controller to the presenter, which gave back a UI state which the fragment or view controller could then display. So you may know this technique way better by its technical name, which is unidirectional data flow. And it allows you to have the view you're working with be real dumb and puts most of the work outside anything that gets passed to the screen. And despite all of the talks that I've seen extolling the benefits of unidirectional data flow, particularly over the last couple of years, the thing that finally made this click for me was Swift UI. And that's because Swift UI is architected to have these representations of views that are lightweight structures which are used to drive the display of the view rather than actually being the view. The huge advantage of this approach is that creating and particularly destroying your UI state becomes something you get used to doing on a very regular basis. If instead of treating your UI like a precious baby to be passed around gently, you instead decided, you can just go ahead and knock that over at any point with very few consequences, then creating these methods that vend UI state and assume that it's going to change at some point makes everything that you're doing considerably simpler. By the way, fun fact, between me and my fiance, this is now the third talk that this cat GIF has appeared in. This is our cat. Anyway, with SwiftUI UI, the whole concept is that you create a structure that represents your view. And you're not actually changing the view directly, you're changing a backing variable. And when that backing variable gets changed, the body closure will get re-rendered, and you've simply returned a new text object that the system can trivially reuse to re-render things. And what this ultimately comes down to is that having less mutable state means you can more easily represent a single state without having to have long-lived references to other things. So TLDR, try to use immutable state objects rather than hanging onto references, because otherwise you're going to get really nasty retain cycles. Nobody wants that. I want to move on a bit to some stuff where I thought that, at least on a theoretical basis, it made some sense to share information between iOS and Android. And for the most part, I wanted to avoid sharing UI. There was one place where I've long tried to allow for some code sharing, and that's within the definition of general styles for an application. In particular, sharing the key semantic colors of your application across platforms can help you keep a coherent brand, even when you're using platform-specific UI. And again, this all made sense in theory because most of the time, you're going to be using colors which are easily represented by hex strings. And if you're using raw strings, you might as well just sort of throw all that into an enum class that takes a string parameter of the hex code as a color, because then you can write a few helpers to get the red, blue, and green channels. Then you can easily make a Kotlin extension on UI color, which allows you to use the color programmatically on iOS. And you can also make an extension on the color enum class to translate it into an Android color, which can be used programmatically. The problem will come when you show this to your per-platform devs, who will tell you they don't actually use colors programmatically. They either use XML colors on Android or asset catalog colors on iOS. So you start to wonder, is there a way to keep this information centralized within the Kotlin native library, but still work in a more developer-friendly fashion per platform? And suddenly, Galaxy Brain mode starts to kick in. What if you could take those colors and generate a resource XML file for Android and some JSON files that go into an asset catalog for iOS? Wouldn't that be nice? Turns out you can do this because I did it. It was ever so slightly convoluted. I wound up creating KTS scripts, which are small Kotlin scripts that can be run standalone, with some help from the kscript command line library, which was first highlighted at the original KotlinConf. The really important thing it allows you to do is import relative files as dependencies. And since my color enum class didn't depend on anything else, I can import it without having to import anything else to access the class. And then I was able to use it within the script like it was part of the same project. Now, combining this enum class with another library to help with the XML allowed me to output the resource XML necessary to have a perfectly at-home set of color resources on Android. And then I was tired after that, so instead of a real JSON library, I just used some extremely dumb string replacement to create a bunch of JSON files and folder structure that, loaded up as an asset catalog in Xcode, allowed me to use these colors in storyboards and as semantic colors throughout the application. Now, sadly, I did not make it to Universe Brain phase with this. I did at least get it working at something which could be launched by a Gradle task. Though when I tried to get this working off of changes to files, I spent a comically long time achieving absolutely nothing other than giving myself a terrible headache. But I did finally realize that I could look for the tasks in Gradle and be able to run them pretty easily by just double-clicking on them. And given that semantic colors don't really change that often, I decided I was basically okay with that as a trade-off for getting native-ish colors in the application. So now that I've talked a little bit about some of the things of questionable wisdom that I have built, I want to talk a little bit about a couple of libraries that I basically could not have built this application without. First thing I want to talk about is how awesome the combination of KTOR and Kotlin X serialization are. Because these two libraries work together, you get end-to-end handling of your network and parsing code. The server part of KTOR can handle receiving requests and returning data, and the iOS and Android client parts can handle making requests and receiving requests. And again, the really nice part of this is that it works on all three platforms I was using automatically. And the parsing is really handy because you can annotate something with serializable. Not only can it be parsed by your apps, but it can be serialized by your server. So you never have to worry that something's going to have a different name on the app or the server. It's always going to be the same because it is literally the same class. And this is also developed by JetBrains. It works super, super well with KTOR server and the KTOR client libraries. I was actually super impressed by how well this works because KTOR was released even before relaxed mode was a thing in native coroutines. So it uses a single-threaded version of coroutines. And as a mobile developer who has constantly been warned away from doing anything network-related on the main thread, I was initially very surprised to find out that this worked fairly well without ever setting off the main thread sanitizer on iOS. By the way, concurrency on Kotlin native can be really complicated. If you want to learn more about this, you should definitely watch Kevin Galligan's talk from yesterday about Kotlin native concurrency. He goes into a ton of detail about how the concurrency model works. I'm going to tell you a little secret, though. Sometimes the model doesn't quite work with everything. If you actually look under the hood on some libraries, you can find out what the cheat codes are that these libraries are using to get around the limitations of multithreading. And in the case of KTOR, they're somewhat brilliantly using an NSURL session delegate object and forcing callbacks on the main thread in order to keep everything at the Kotlin native level on a single thread. You're still firing things off on a non-main thread. You're just making iOS do all your dirty work for you. Another fun way to work around some of the limitations of threading is to only ever send objects out of the network from your code, and then to return totally separate objects rather than manipulating existing ones. A really easy way to do that is to use a database layer to persist everything, and only fetch things out of the database as needed. SQLite is a really great choice for this, because on the surface, you get one database type that works across JVM and native, and allows you to use that as a way to handle having data come in on one thread and then be able to use it on another thread. Now, you are going to give up a few things at the platform level. Core data and Room are both really tightly integrated at the system level for iOS and Android. The thing is, this isn't actually as much of a problem as it used to be. On Android, you can use SQLite's coroutine flow extensions to get yourself a really nice flow object that you can then turn into live data pretty trivially. And you can also turn live data into a flow as well. On iOS, while you're still giving up tight integration with NSFetch results controller, with SwiftUI you wind up losing most of the advantage of that class and gaining back the ability to use other forms of data storage and still get great UI performance. The most critical tool in terms of deciding what needs to be native and what doesn't is knowing why you want to use Kotlin native in the first place. Because this is a really critical piece to knowing where to draw the line in terms of what needs to be in Kotlin native and what simply should be native iOS or Android code. Are you using Kotlin native because your existing mobile team is stretched too thin to cover everything that you need to do? If you've got platform-specific developers, it can be really helpful for both code review and for bailing you out when you paint yourself into a corner, which I will tell you from experience is a thing that you will do. But if you're using Kotlin native because of budget restrictions, which make multi-platform the only viable way of getting an app out, hiring a consultant or bringing another developer in to work on stuff that you're less familiar with is almost certainly out of the question. And you may need to gamble on doing as much in Kotlin native as possible. Or, if you're trying to move forward on as many fronts as fast as possible, then you really need to do your research ahead of time so that you are aware of the platform-specific pitfalls that you can run into when trying to move everything forward at the same time. Or, does your interest in Kotlin native stem from the fact that you are super excited to mess around with the latest and greatest and see what you can create? You should consider whether you want to mess around with things in production or build a simpler sample application, not unlike I did, to really suss out what the positives and negatives of Kotlin native are for your platform. Across all of these potential reasons, you need to remember that working with a cross-platform framework is not a good reason to ignore the things the platform itself does, both from a standpoint of how the platform works and how developing for the platform works. If you want to be successful with cross-platform development, you have to be cognizant of what you're giving up that the platform has been doing for you without you not even necessarily needing to think about it. Once you realize what you're giving up to move other things forward quickly, you have to decide if for you it's worth that trade-off. For me, I found that centralizing logic is definitely worth it, but I got diminishing returns as I got closer to the UI because I've worked extensively on the UI for both platforms. I have a pretty good idea of how to do things relatively quickly with that. But your mileage may vary based on both your experience and the team that you're using. Choose your strategy wisely and with your eyes open. And with that, I have finished way early, but we have come to the end of my talk. I wanted to leave you all with a few things to mull over. The first is that Kotlin native can really be a huge, huge help in some things, but you can easily get into a situation where you've built something that seems super cool, but isn't actually all that helpful. You can absolutely move way, way faster on some things, particularly when complex business logic does not have to be duplicated across platforms. But anything that's trying to work on multiple platforms is going to have trade-offs in terms of how it works and how easy it is to use. Keep those in mind when you decide what to make native and what not to. Prioritize the experience of your developers. The lessons learned from Airbnb, DROPBOX, and many other places where developers have tried to use cross-platform frameworks are littered with stories of cross-platform failing because developers were at best unenthusiastic and at worst outright hostile to working in a cross-platform framework. Making the experience better for your developers will absolutely help you do better with cross-platform frameworks like Kotlin multi-platform. And finally, when you're deciding what trade-offs to make, remember why you are doing this in the first place. You can have far greater success if, as Alec and Ben were saying yesterday, you have a thesis statement that helps you evaluate when to put things into a shared library and when not to. Thank you very much. Remember to vote. And I'm going to open the floor to questions because I ran super short. So thank you all for listening. So I think we've got someone with a microphone. Okay, got one question back there.
Hello? Excuse me. Yes. Okay, so one thing I'm thinking about with respect to this is if you're an Android developer, you're totally comfortable with Android Studio and writing Kotlin and stuff like that. Let's say you're trying to sell this to your iOS developers who have never installed Android Studio, you know, and have no desire to do it. Yep. The question that I keep thinking about is like, you know, the other side, you know, iOS types, like what do they have to have? It's hard for me to know exactly how to ask the question, but like, are they going to have to install Android Studio? Are they going to have to run, you know, the app from Android Studio? Like, how should the iOS developers, what will they need, and like, how can yourself being an iOS developer, how can you sell it to them?
That's a really great question. I think one of the things that happens when you create these cross-platform cross-platform libraries is that you actually create a framework, which is the same as any Swift or Objective-C framework that you would get out of Xcode. And so you actually essentially just add a build script run phase that just calls into a Gradle build script, and that builds the framework. It takes advantage of all of Gradle's, like, did anything change? Okay, good, I don't have to rebuild all this stuff. So you're not really getting these longer build times that you could potentially get if it were having to rebuild it every single time. So that's really helpful. If you're only looking at it from that perspective, it can basically be like bringing in any other library. The other thing that I think is a really good selling point for iOS developers is that it lets them focus on the iOS-specific part of the application. Platform-based developers really, really, really enjoy working with the platform-specific aspects of their platform. There are some people who really, really love getting deep into the mess of how data is stored on both iOS and Android, but there are tons of iOS and Android developers who would rather just like make things go boing all day in whatever way they possibly can than mess around with all of this business logic, which is ultimately what runs your application. Letting individual platform developers focus on the platform that they're excited about, I think is a really good way of selling, hey, we're going to take all of this stuff, get it to a point where when it breaks, there's only one place it needs to be fixed, and then you can focus on doing things the right way for your platform. That, I think, is a huge, huge, huge positive for iOS developers that I think is sort of underestimated by Android developers when they're looking at this, because Android developers are always looking at this as like, ooh, I can do everything in Kotlin, fantastic. And iOS developers are often more reluctant to do that. Does that answer your question? 2 thumbs up. All right, cool. Any other? Got one down here? Down here.
Hey, so you said at the start that Kotlin Native wasn't designed to like kind of do the whole thing. It's just designed to kind of keep your business logic.
I think I would say that it's not necessarily that it's not designed to do it, but I think it's something where that is absolutely its strength. It's definitely something where looking at the strengths of JetBrains in general, JetBrains is really amazing at building tooling and languages. And they don't necessarily have people who are deep experts in the UI of either platform. And so it's something where that was not a primary focus of the initial development of Kotlin Native. The focus was, how do we share this logic much more clearly? There's definitely ways that you can share a lot of information about the UI. There was a talk from the Airbnb folks about how they're using backend-driven UI. One thing that you could do with Kotlin Native is you could have something similar where you have sort of a general description of what your view hierarchy is going to look like and have that at the Kotlin Native level rather than having to fetch it from the backend. You lose some flexibility in terms of how easily it's able to be changed, but you also gain some performance in terms of not having to go to the internet to know how your UI is supposed to render. Sorry, did you have more? Okay, excellent. Let's see, I see the guy with the microphone running around. Got another question down here. There we go. Hi.
Hi. I'm wondering, like, I'm an iOS developer, and I don't know much of the Kotlin, but I'm talking like Planner guys and so on, and I'm thinking, like, with this, like, Kotlin multi-platform approach, isn't it, like, still at some point converging, like, to having, like, 3 platforms at the end, like iOS, Android, and the multi-platform?
Yeah, I agree with that. I think one thing, anytime you're using any kind of cross-platform frameworks, you're never just like, oh, well, we'll get like 2 for the price of 1. You always have N+1 frameworks. You always have iOS and Android and something else. So I think this is sort of the idea is that the place where the overlap is much closer to what iOS and Android developers already know. So you're working, particularly because you're working with Android developers who already know Kotlin, who already know how to debug a lot of this stuff, that really helps reduce the communication overhead in terms of, okay, how do we figure out how this works? And I think that, for me, is a huge draw for Kotlin Native because it allows you to say, okay, like the number of people that we need to debug a problem suddenly contracts. It also is something where Kotlin as a language is way more similar to Swift than Objective-C was to Java, or Objective-C is to anything. And you know, I think it's something where, you know, once you get past like, oh, var and val are different things, and you have to use a semicolon, or you have to use a colon instead of an arrow to return things, and you use the arrow instead of in to indicate that a parameter is coming in. Once you get past those little sort of small things, it's reasonably easy to understand Kotlin code when you look at it. You know, you may not necessarily fully understand it, but you can at least get the gist. And I think that for me is something where I think that was a big help, and I think that's one of the things that really makes Kotlin Native different from other multi-platform solutions. It doesn't absolve it from the problem of you know, you have to know how the multi-platform piece of it works in order to debug stuff, particularly knowing that all of the stuff that's generated from Kotlin to be used in iOS, all of that's using the Objective-C runtime. So there's some stuff that you may be making assumptions about knowing Swift that you might be very wrong about because it's all in the Objective-C runtime, and all sorts of weird things can happen there. So that's something where I think it makes the problem easier to tackle, but it does not remove the problem.
Hello, fantastic talk at first. I had a wild dream a couple of months ago because we have like kind of several multi-platform solutions right now that tackle different things. Kotlin Native comes from the backend side, Flutter comes from the frontend side. Yeah. And while I look at Flutter and see, okay, I have to write kind of a JavaScript language again, I don't like this, and I have to deal with a whole couple of libraries that I don't know and that I actually don't want to know. I figured, okay, can we somehow marry Flutter with the front end and Kotlin Native with the back end? Is this something that you have maybe tried out or thought about, or what's
I have not personally tried this. At App DevCon earlier this year, there was a talk where someone actually did talk about doing this, where using essentially what you just described, Kotlin native for the back end and Flutter for the front end. It seemed like it was very difficult. It was definitely something where, when you take the problem of adding a cross-platform framework and then you also add another cross-platform framework, you're kind of exponentially increasing the number of problems that you have. One thing that I believe is possible is I think you can use Kotlin.js to write Flutter code. Does anybody know about this? I feel like I've heard this at some point. Everyone's looking at me like I'm a crazy person. Okay, cool. But yeah, I think it's one of those things where, it's definitely doable. I think the question is the amount of time that you're going to be spending fighting with both platforms worth the amount of time that you would be saving by either picking one and going with it or using neither?
Yeah, so basically it's better to have separate UI implementations, just go with Kotlin native then.
That would be my take on it, but I think it's also something where like I said, I have been beating the drum of UI should be platform specific for literally ever, and so I want to make sure that it's very, very important to me to make sure that UI is very platform appropriate. I know that Flutter is really trying to keep that doable, but I think when you're trying to work with two different UI systems, it becomes really difficult to do that very quickly. So yeah.
Okay, thank you.
Thanks. I think there was one more. Anybody else? Got one up there.
Hi.
Hi.
I wanted to ask more about your experience using Kotlin native for core device functionalities like Bluetooth and GPS, where it is already very hard to program, because especially in Android, where you have almost every device behaving differently. And how will it work with Kotlin native?
That's a really great question. I don't have a ton of experience doing that. The person that I would recommend that you talk to is Ahmed. I can't remember his last name, but from Kareem. He talked quite a bit yesterday. That talk is also really good. I recommend you seek it out if you weren't there yesterday. He talked quite a bit about the fact that iOS and Android have very different systems of dealing with GPS in particular, just because they basically make like an Uber-style app for drivers and passengers, and the driver app is basically entirely done in Kotlin native. And when you're dealing with Android, you've got the option of either getting like pure GPS or a fused location, which takes a bunch of other stuff into account, and you might handle each of those differently. Whereas on iOS, it's just like, here, have a location. Where did it come from? Who knows? Which is why my phone always shows me in Madison for like at least 2 days after I come to Europe. But it's one of those things where being aware. This is another place where being aware of the different ways that platforms handle things can help you decide: is it worth it to combine at least some of this logic, or is this so platform specific that it's just not worth it? And that would be my advice, is sort of, before you get started with something in cross-platform, just take a look at what your options are for each of the platforms and see if there's a way to sort of come up with some kind of intermediate representation that is workable. Let's see. I think I see a 5-minute warning. Does anybody else have any questions? All right, got one right down there.
Hi.
Hi.
In situations where you have a C++ library that contains some of the business logic that you need, can Kotlin native or the Kotlin multi-platform help with that?
That's an excellent question that I actually don't know the answer to. My understanding is, yes, it is somewhat easier to work with some wrappers around C++ than sort of just trying to work purely with the JNI. But honestly, that's not something that I've worked with before. I think it's something where the first step is to take a look at it and see, okay, if I'm using pure Kotlin, how can I talk to C++? And if you can get to that point, then it becomes easier to sort of take the existing work that you've already done and potentially wrap it in a way that's easier to use in Kotlin. How that works in reality, I am not really sure. So I'm sorry, I don't have a good answer for you on that.
Okay, thank you.
Another one?
Yeah, so how mature is the build system around this? So you usually have coming from Android that you sometimes struggle doing some of the Gradle parts, getting the resource generated, all this distributed. Yeah. Is it easy to get ongoing? So from the Android side, I don't really know what to target. Giving something to the iOS developers, is it sort of easy, or would I have to dig into that infrastructure too?
So I think one thing that's really nice is when 1.3 came out, they put out a new tutorial for how you can get set up with Kotlin native. And that covers setting up all sorts of stuff in Gradle in terms of what all your presets need to be, what needs to be set up, and then how to create a simple Gradle build task that you can just say, okay, like here's a piece of information, now give me an entire iOS framework. Having all of that sort of already laid out for you helps a lot. If you have fought with Gradle before, you are probably familiar with the whole like, all right, I need to be on Gradle version 5.4.1 for this library and 5.3.2 for this library, and now what do I do? That is less of a thing than it was before. My understanding is that some of the changes to klibs are probably going to make that a little bit better as well. But I think the biggest thing that I found it to be difficult about it is that because the platform is moving so quickly, a lot of the articles in terms of like how do you do this are very outdated. And so you will bang your head on a desk a lot, but if you've fought with Gradle before, it's actually much easier just because you kind of know how to throw things at Gradle and go, all right, did that work? No? Okay, how about that? Okay, how about that? And then you just eventually say enable metadata, and for some reason everything works, even though metadata is in the current version of Android. I don't understand what's going on with that, but anyway, yeah, that's definitely something where Alec and Ben talked about yesterday. One of the really big things you can do to help yourself is set up the tooling as early as possible, because then you can really just get all of that nonsense out of the way while your project is still really small, and be able to just take advantage of that work as you continue to go. So getting as much of that tooling stuff set up as possible, including like CI and stuff like that, super, super helpful if you do that early. Does that help? Cool. All right. I think that's it. All right, cool. Thank you all very much for your really good questions. I really appreciate it. Let's see. I'm going to say, how about you with the Objective-C question? Or the iOS question, red sweater, staring at me, can't tell if you're acknowledging me. And then, oh, there was another one. Let's see. I think it was Andrew. Yeah, sorry. I know I used to work with that guy. But it was a good question, so I'm going to have to give him a book. Anyway, thank you all very much for coming. I hope you enjoyed, and have a great rest of your KotlinConf. All right.
So let's start. Hi everyone, and so many people and almost normally distributed. I'm really worried because it's the biggest audience I've ever had, and the biggest English-speaking audience because it's the very first talk in English ever. So, and today we are going to talk about whether it's possible to use Kotlin for data science. And spoiler, it's possible. So, let's start from the name of the talk, data science. I'm expecting that if you are here, you are familiar with data science and you know what data science is, you know the general concepts, main instruments, and so on. And it's the right point to verify this assumption. And who of you feels confident in data science? Okay. Okay, and who just think that it's a buzzword and it would be interesting to play with data in Kotlin at some point? Me also from the second group. And like a year ago, we started, after the last KotlinConf, we started a project called Kotlin for Data Science at JetBrains. And today I'm happy to share some progress and what we are working on for making this experience more pleasant and more enjoyable. And I do believe that the best way to show everything is just a practical example. Usually it's not that easy to find a piece of data that could be interesting for the whole audience, but this time I think that I found such a data set. And today we are going to analyze Kotlin Slack. Who's on Kotlin Slack? Quite a lot of people. And use this link if you are not in Kotlin Slack because there are lots of interesting discussions. And today we'll try to analyze the structure of this Slack community, some patterns, some topics which we are discussing, and basically that's it. It sounds interesting? Cool. So when we are talking about data science, usually we think about two words. First one is Python, and we will talk about it a bit later. And the other one is Jupyter. And Jupyter basically, who knows what Jupyter is? Yeah, so it's basically the most popular tool in data science. It's kind of interactive shell. You have different cells, and some cells could be just a text with markdown syntax, even LaTeX formulas, and other text are code. And you can execute this code with the help of kernel. Jupyter comes with IPython kernel, but one can write its own kernel, and we wrote Kotlin Jupyter kernel. And today, I'll show how it works. So it's a demo time now, and first, how to install it. Actually, you have to use Conda at the moment. Who knows what Conda is? It's kind of a package manager, hugely popular in data science community. And you type just Conda install Jupyter kernel -c JetBrains, which means channel JetBrains. And it tries to resolve your environment and install the package. And surprisingly, it's already installed on my laptop. Next, I can just run it. And here it is. We have Kotlin type of notebooks. Let's create it and type something like 10 plus 10. We are still waiting while the kernel starting. And yeah, here it is. Kotlin and Jupyter. It could be Python or Scala. So let's write something more meaningful like something like, oop, wrong one. Hello, KotlinConf. And execute it. Whoa, print what? Print clone. Cool. It works, and now let's take a look at our data. So we have a data folder here, and there are many of folders with the name of channels in Slack, and in every folder we have a number of JSONs with basically messages. And finally we have several JSONs, one for channels, one for users, and integration, I don't know what is it. So let's take a look at users. So it's a JSON with, so it's an array with objects, and every object has its ID, name, time zone. Time zone, it's interesting because it gives us ability to analyze geographical distribution, and some profile information. By the way, it's the profile of Hadi Hariri. He created this Slack. Thank Hadi. So, and well, we need some library to read this JSON. I personally love Klaxon. So let's go to Klaxon page on Verb on GitHub. And to edit, I need JCenter, and here are coordinates. So I can write something like this. Add file. File repository, and add JCenter now, https jcenter bintray.com. Then I can add a dependency, depends on, and copy and paste these coordinates here. And finally, I also need to import Compist and Klaxon. That's it. Now we have a Klaxon object. We have a Klaxon object, but we lost 95% of all data scientists because it's weird. Nobody wants to write such stuff. And it's really, so now we can write something like use Klaxon, and basically with the same result. So it's kind of a magic, and it automatically downloads the dependency in a local repository and write all necessary imports and so on. Okay, so now we need to create some data class represents this user. I will actually use only ID and time zone label. So data class user val ID of string and time zone label also string. Now we have this class, and let's read users. For users, Klaxon parse array. Unfortunately, we have kind of completion, but it's not real completion here. So it's kind of, it can complete only local variables. So we will improve it later, I hope so. So, and it needs the string, so we will use the file data users JSON read text. And we need import file as well. Import Java.io. Oops, Java.io. And something goes wrong. It's because sometimes we don't know time zone label. Undefined. now we have users object, and it looks like this. Let's take a look how many people on Slack. Oh, this user object is nullable, but we already know that it isn't, and it's kind of dumb. We need to think how to improve it later in REPL mode, but for now I'll say that no, it's not null. And yeah, now we know the number of people in our Slack, and we can filter it, for example, using time zone filter, it time zone labor contains, let's say, Europe. And how many people in Europe? Users, time zone label. Yeah, sometimes it's really hard without completion. Contains. Cool. So 7,000 people from Europe, and we actually would like to have a distribution and to look at distribution. So we need some plotting library, and we have one. Let me introduce Let's Plot. So Let's Plot, it's a library which we are currently working on. It's inspired by Grammar of Graphics. Who've heard about Grammar of Graphics? So not so many people. So the idea is that the whole plot is split on into different parts. One is data and lots of layers and some statistics attributes and so on. And in data, we have series, and every geometry primitive can have mappings on the series. Basically, that's it. And there is a ggplot2 package in R, basically one of the standard de facto in R, and it's hugely popular because it's really handy. And the other reason why we decided to work with this library is that it actually plays really well with Kotlin DSL syntax. But currently we are providing kind of R syntax for this. So it's all Kotlin, it's multi-platform, and it gives ability to create interactive graphics from Kotlin or even Python API because of the native target. Lots of different targets, it looks like this, and let's try to use it. So I'm continuing with the demo, and I say that let's use Let's Plot. And here, I need first create some, let's call it time zones. And it's basically the data part of the plot. So it would be a map, and the first series called time zone, to users map it time zone label. Here it is. So now let's plot this data. Let's plot time zones. No layers on plot. Yes, because we didn't add them. So let's add some statistical layers, so like start count. And here it is. Also, we can add some size. Cool. Now we can clearly see that the biggest part of the our community from Central Europe. Also, lots of people from Pacific area and India, Central, something like this. And basically, that's it about users. And let's now analyze channels. But before starting with analyzing channels, there is a really meaningful question is whether it's the only library which we can use with the kernel. Obviously, it's not. And kernel comes with config.json file, which contains all default repositories and then number of libraries. Every library has its alias, then repository dependencies, imports, and initial code that runs when we execute use magic, and the very important thing, renderers. So when we see that the result of the cell is of the class like this, we can apply some transformation on top of this class and draw it in a convenient way to user. So I know that there are many library authors in this auditory. So if you want to contribute your library to the community, you can contribute to config.json, and it will be easy to use your library. Or you can create your own config and put in your home folder, and then all these changes will apply only to only locally. So one of such libraries is Gradle, and written by Holger Brendel, and it's a library which basically gives us data frames, and it has interface in Kotlin, and it's all written in Kotlin. So I already created some notebook for this, no more typing, and channels. So I use Gradle and let's plot, and kernel starting. Sometimes it's too long. Okay, then I actually read data frame from JSON called channels, and I can draw this data frame. So data frame is basically a multi-dimensional array with named columns, and I see that there are columns for name, for members, and members now it's a string with JSON array. Actually we can change it a bit. So we now map this column with actually we rewrite this column with the same name, and we will map it with the help of this function. So let's take a look. So now it's a real array. So next, we want to add column with a number of elements in this list, and here it is. And by the way, because data frames are kind of dynamic structures, we don't know the types in compile time. That's why in all such mappings, we currently need to specify it explicitly what kind of column we are working with. So it's a bit tedious, but at least it's type safety. So we'll think how to improve it in future. So then we'll filter out all empty channels and actually all small channels, and take only columns we need, like ID, name, members count, and sort them at the end by the count number. So let's take a look what we got. Something like this. So it's a list of top channels. Now let's draw a distribution like we did last time for users. And we see that first 7 channels are much bigger than all others. Do you know why? Because they are default channels. When you join Slack, you are already a member of these 7 channels. And so, okay, so we see that people are not evenly distributed between them, obviously. And also general, you have to be in general on Slack. But let's try to calculate intersections between all these channels. So I'll create intersection which from channels, and for each row in intersection, I will go and add a column which with a number of people that intersect this column and this row. So basically, I'm calculating how many people are common in different channels. And let's take a look at intersection now. Yeah, so now we have lots of columns for every channel with some intersection measure. It's I've normalized it by the number of people in the channel. And let's draw it And for this, I will use one more primitive called geomTile. And it needs a pairs of x, y, and the value. So I will use gather function on my data frame to combine everything in such pairs. So I got this data frame now with the pairs of channels and measure of intersection. And let's plot it. It's big. So yeah, let's take just a few of them, like 70. I didn't execute it. Oh, yeah, sure. Channels, intersection channels, take 70. Yeah, this image is much clearer. So obviously there are ones on a diagonal and ones in general, because everyone on general channel. But there are also lots of different outliers, because we see that generally the intersection measure decreasing with the size of channel. But these outliers, it means that some channels are really interconnected. And we see that, for example, iOS connected with multi-platform, Android bindings with Android architecture, and Russian feed with Russian. Also, we can see, can you see this kind of cells? Some channels are more isolated from the others. And let's see, what are they? Like Brazil, India, French, Polish. So it means that we have strong local communities, and because of language barrier, they have less number of people in common with other channels. But let's do a trick now. Let's take this similarity matrix, convert it into matrix, so we need to invert it, 1 minus. And now run TSNE algorithm on this. It's a kind of a physical analog when you have number of points with elastic strings between them, and when you try to find the kind of a position which energetically the best one. So fortunately, I found a library for this written in Java, and so let's try to make it. And it needs this similarity matrix, X, and I tweaked several parameters, and now we can plot it with the help of geom points. And here it is. But actually, all these big channels, they actually spoil this matrix. So let's remove them. We'll take, say, tail. Unfortunately, there's no skip method. Channels and rows, -7. And row. And so let's recalculate it. So now every point has a single channel, and the closer points are the bigger intersection between these channels. So let's take a look at these clusters, like Android architecture, Android bindings here, Vancouver, Latvia, China, Hong Kong, close but not the same. Nigeria, Minnesota, contributors, language proposals, they are all EAPs, stdlib, Meta, so they are all close to each other. So it's a really interesting view on our Slack channel, and it's written, everything written in Kotlin. The last example, which I'm going to show, it's a very important thing, it's integration with Apache Spark. Apache Spark is a very popular framework for analyzing big data. But you can run it locally. It's a bit tricky, but we managed to run it locally. And everything is easy as just writing use Spark. I won't run it because it would be too long, because here I'm reading all messages and drawing them across the time. So, but basically everything is pretty clear. Like I have a Spark context already because of this initialization block, and now I have a Spark read some data with some predefined schema, wrangling it a bit, and get then messages with timestamps in 2 different formats and name of the channel. Then calculate the top channels by grouping it by channel and counting them and sorting descending. And now we have different top channels by the number of messages. And it's completely different image because we have now general, obviously, but then tornado FX. And it was a small channel in terms of number of people. And then Android, and so on. And then we can join them together and get the number of messages together with a count of messages in the channel it contains. So, and finally, I can plot them. For this, I will use geom density and plot them all together and see when different channels were popular, like Cobalt was popular in the beginning, Tornado FX, then again Cobalt, JavaScript, but now rising multi-platform and Arrow. And we can plot them because these plots are normalized. We can plot them one by one, stacked layered. And all of this with the help of Let's Plot library. Cool. So, and basically, I think that's it about using Jupyter kernel. Actually, I didn't run this last script because it was too long. But what I can do, I can scale it up and go to cluster now and try to run the same script on cluster, same notebook. So in this data engineering world, there are a bit different stack of technologies. And also, there's one more popular notebook called Apache Zeppelin. And we wrote a Kotlin interpreter for it. It's kind of kernel for Jupyter. And we already merged it into master, and it will be available out of the box starting the next release. And it also has Spark support. And the cool thing that you can share the code with Jupyter. So let's switch back to the browser and go to the cluster. Here we have messages. Basically the same notebook with some cosmetics on top of it, because there are a bit different ways how to represent data frames and so on. But yeah, the result is basically the same. We plotted all this stuff together. It has its own plotting engine inside, so we just relied on it. And so the main idea here is that you can share not only code, but also experience on different stages of data science. You can start playing with data first locally, without cluster, and then scale it up and play in cluster, and it's really easy to start cluster as well. So, and if we take a look at div, you see we actually didn't change a lot when we adopted this code for running cluster. We changed the pass to data, some additional regex because this data lays in a different format, but basically that's it. One more example. So now on cluster, we can do something more heavy. So I've played with word embeddings. And here again, like in, we read the data, then we will split the messages into different tokens based on some regex, filtering out how it's called, HTML tags, some code snippets and emojis. And finally, we will remove also stop words, so meaningless words. So now we have them like divide out the, as all these words could be filtered out. And let's take a look at the result. The result is here. So early returns like that are code smell. Early returns like code smell. That's it. And actually, we are working now with 1 gigabyte of data and playing with it on cluster in real time, and everything was really fast. And it's a quite small cluster, actually, just 8 nodes. And now we can calculate word embeddings using these tokens. Do you know what is it? It's a kind of when we get word and create a vector which associated with this word based on its context in original text. So, and it will take some time, like 10 minutes, I think. But fortunately, I already calculated it and saved, so we can now load it. And now we have this model. And this model, for example, can find synonyms. Let's play with it. So let's try to find synonyms for KotlinConf. Attending. DroidCon. What else? MPP. Multi-platform. Cacao pods, why they are here. iOS, GVM. Okay, let's try Breslov. Andrei talks Russian, keynote, talk hearing. It knows something. So based on this model, we can now take all these words and basically try to cluster them together based on using Kamin's clustering algorithm. So it's basically tries to find clusters of almost uniform size. It will take some time. Here they are. So let's take a look at cluster sizes now. So we created 42 clusters, and they are almost all the same size. Now we can, for each cluster, find its center and find the closest words in this space of words to the center to describe the cluster. So let's run it and show this data frame. So now we have a cluster 0, and the closest words to is like paradigm, high level, academic, MATLAB, hipster. Idioms, what is it? Object-oriented. Okay, and now we will do the same trick like we did for channels. We will put them all using TSNE, and it also will take some time because the size of data set is much bigger. It's pending now. So basically, I'm creating here the same matrix with distances between words. And then I will try to plot all the words based on this distance to understand what are basically the main topics in these messages. So yeah, now I'm already running the and iterating the plotting algorithm, and let's create the final plot for it. We'll try to analyze it a bit. Later, we can use the same data frame, for example, for creating some prediction model. For example, you type a question, and then it automatically determines which channel you should write this question to. So, oh, here it is. We have a map of words with different clusters. Here's some tiempo. It's some language which I don't know. Sierra, Fedora, Patches, Intel, so it's something about hardware. Server-side, full stack, Vardin, Vue.js, so it's about some web technologies. There are also 2 clusters here. I don't know what it's about. So it's one more view for analyzing it. The last but not least thing here is big data tools. Have you heard about it? It's a new product from JetBrains. It was recently released as EAP. And what it actually can do, it's a plugin for IntelliJ IDEA. And here we can establish a Zeppelin connection and connect to Zeppelin server using its path. Let's put it here. And all my notebooks are here as well. And it's like a Zeppelin but on steroids. And now it supports Kotlin as well. Originally it was created for Scala. And it's basically the same notebook, and you can play with it. There's also charting. Probably they are not so good as in original one, but it's still really a good beginning because we do believe that tooling matters. Well, and that's it about tools. Now let's talk a bit about libraries. So there are a lot of them. In Kotlin and in Java, there are lots of different libraries. Some of you actually are there. You are authors of some of them. So, and you can use them for data science already, but there is something in common between them. Like in Python ecosystem, there is a NumPy, and all libraries are built on top of this. And that's why we created some experiment, and we created Kotlin NumPy. So let's take a look at code. It really looks like a NumPy, and really similar in terms of syntax. And but the difference is that it's statically typed API. One more practical example, simple neural network. And if you are familiar with NumPy, it's basically almost the same syntax. But there are some differences. So if I run this code on the left, the first statement is OK. But the second one will fall on runtime because I'll try to incompatible types. A is basically of type int, and it couldn't be multiplied by double. Because internally, NumPy is statically typed. In Kotlin, it would be just an error in compile time. And it's pretty important because, you know, there are sometimes really heavy computations, and it's really big pity when you lose all your computations in the last line. Internally, it's not a new library. It's bindings to NumPy. So we created a lightweight KTND array, and it has pointer to NumPy, and they both has pointer to the same block of native memory. And it means that we can actually write algorithms using this block through direct buffer. And currently, we covered like almost 55% of NumPy API. It's pretty a lot. It's array creation, manipulation, slicing, stacking, binary operations, all of this stuff. The cool thing about performance, you may imagine that it would be much slower, but surprisingly it isn't. And currently only indexing is slower, about 1.5 times. But many of other operations, especially iteration through the whole collection via iterator, is much faster. And that's great, because it provides us a way to write our own libraries on top of this with a good performance. And the cool thing that we now can wrap other Python libraries. If you have some Python library, like for example SciPy, and it depends on NumPy, when it needs a NumPy object, you can give it NumPy object from corresponding Kotlin NumPy. And again, when we are returning NumPy object, we can return a Kotlin NumPy object as well. So let's sum up now. Today, I will show several new things. Actually, they all were released last week, or actually even yesterday. Jupyter kernel, Zeppelin interpreter, Kotlin and big data tool support, and 2 new libraries which are still experimenting, obviously, Let's Plot and Kotlin NumPy. And the main idea behind all this work is that we are actually trying to make Kotlin as a common instrument for data scientists, data engineers, and software developers, actually for us. So, but the thing is that it's ready to try right now. We need your feedback, and we will act on it. So everything you need is behind this link, Kotlin Data Science. And finally, several words about our roadmap. Please join us on Slack. Take a look at other data science talks in KotlinConf. There was 2 of them yesterday, and we are open to contributions. And regarding contributions, what's the roadmap? We are going to improve tooling in Jupyter and create a new plugin for IntelliJ IDEA that will actually work like big data tools for Zeppelin, like a Jupyter plugin for Jupyter. So we are going to improve tooling inside Jupyter because you saw this nightmare with typing and so on. Also libraries. The main project now is Kotlin API for Apache Spark, and we will continue to play with Kotlin NumPy and evolving Let's Plot. We already understood that we need some language changes, and I will bring them to every design meeting. And finally, there are something that I've already mentioned, that in some cases, for example, data frame, it's some object with dynamic by its nature. And we need to have a way to calculate static APIs for it on the fly, and it would be really convenient. So, Kotlin Data Science, and thank you all for coming.
I think it's better.
No? Yeah? Okay. Can you hear me? Okay, yeah. Okay. Welcome to our talk, and thanks for coming. She is Amanda Hinchman-Dominguez from Chicago, where she is the organizer of the Kotlin user group.
And this is Raquel Carmena. She's from Spain, and together we work at 47 Degrees.
Thank you, Amanda.
Thank you.
You're awesome. So let's start. Let me tell you a short story. A long time ago, in a galaxy far, far away, Arrow Library was born. Who of you are familiar with Arrow Library? Woohoo! Perfect, thank you. Okay, but don't worry, because it's not necessary to be familiar with Arrow Library for this talk. For those who are not familiar with Arrow Library, it's a functional companion to the Kotlin standard library. And it seems a library is the common way to add more functional capabilities to a programming language. Let's see some examples. Cats library for Scala, Bow library for Swift, Bubber for Java. However, we wanted to add more ergonomic features to the language that don't exist in Kotlin or the standard library, and that require to reach out the Kotlin compiler. Let's think. We use the Kotlin compiler to compile the source code in order to get the bytecode. And the Kotlin compiler doesn't transpile Java code, as some people think. It's a compiler. And at the beginning, with Arrow, we were focused on the source code. What if we shot the arrow to another direction? What if we shot the arrow to the Kotlin compiler? So it was the time to contact the Kotlin community to get more knowledge about it. But how? So Kotlin provides several sources of contact to follow one of the principles of the pragmatic evolution, which is to stay in a constant feedback loop with the users. Let's see. Sources of contact. Maybe the most known is the Kotlin lang Slack, right? Who of you are in Slack? Everybody. Very useful, right? Besides Slack, there is a Kotlin forum for discussions, an issue tracker, and a way to contribute to the language. That's KEEP. It means Kotlin evolution and enhancement process. It's hosted in GitHub, and it holds proposals for the language. Its proposal is submitted as pull requests, and they are also known as keeps, just as keeps. And new keeps, or some keeps, have their own repository
for a specification and discussions. So here we go. We created this pull request to propose adding compile time extension interfaces in the same way as protocol extension in Swift. And at the same time, we realized that the entire community was heavily dependent of some compiler plugins like Android extensions, serialization, all open, all of them companions to the Kotlin compiler because they require more advanced features. But it's not just about creating a pull request. It's really important to receive feedback. And we receive a huge amount of feedback. Look at the numbers. More than 300 messages, 85 commits, 57 participants, 18 reviewers. Amazing. Thank you. Do you want to know more about it? OK. So before explaining what we have done for the Kotlin compiler, we are going to show you how the Kotlin compiler works. Let's see. Firstly, we write some code. And the Kotlin compiler reads that code and models its structure into a tree, also known as the AST, Abstract Syntax Tree. And that tree is compatible with JetBrains PSI, which is used in the IDE. During analysis, that tree gets transformed into another tree, a tree of descriptors, which have a reference to the original AST element. OK, before, those descriptors are very useful during the code generation phase to render the code, and also they are useful for building ID tooling, OK? So during resolution, the code is type check, and including some data flow management like Kotlin contracts or generic constraints. If the Kotlin compiler reaches this point, the source code will move to code generation. And during the code generation phase, we will get the bytecode to be run in any of the available platforms. And everything is done. And now, we are going to explain you how we can add more features to the Kotlin compiler through metaprogramming with arrow meta.
Thank you, Raquel. The Kotlin compiler is always evolving with different APIs, toolings, and plugins available. There are so many ways that the compiler is always growing. And I want to say that arrow meta is just one means for Kotliners to be able to explore creative innovations for the language. And we do this by providing a DSL that removes the surface complexity for subscribing to different phases in the Kotlin compiler. So my mate Raquel did an excellent job explaining how the different phases of the compiler can be gone through in its entirety. But let's take a look at it again with arrow meta. So we start with arrow meta intercepting the AST phase and its resulting models. The quote and template system gives the ability for transformations specifically to the code. So we're thinking about code generation, static analysis, any kind of tree transformation you can think of. If you've worked with IntelliJ IDEA, you might be familiar with its features such as warning messages, pop-ups. And the thing about that is that those features require that compiler plugins provide a special kind of model called synthetic descriptors. Synthetic descriptors contains information like names, Kotlin types, and everything that IntelliJ IDEA needs in order to be able to provide those features that are specific to Kotlin. So the thing about that is when you're writing a compiler plugin, it is the responsibility of the creator to basically manage that synthetic resolution. But Arameta does that for you, so you don't have to. Okay, I made a little bit of a lofty claim that Arameta has the ability to intercept and subscribe to all phases. I stand by what I said. And this includes code generation. So for folks that are less familiar with Kotlin compilers, when we're talking about code generation, we're actually talking about two things. We're talking about IR and ASM. ASM is a library that generates bytecode for the JVM. IR, or intermediate representation, is basically a textual tree that's used to generate bytecode for all other available backends for the Kotlin compiler. So the Kotlin compiler allows you to use one or the other. Arameta provides a user-friendly DSL so that you have the ability to use either, and this is quite wonderful. So we've gone through the compilation process successfully, and we've shown how Arameta is able to work with all those phases.
Thank you, Amanda. And now, let's see some features in detail. We are using Arameta to build plugins for Arrow, but you can create your own plugins as well with Arameta. For example, we can create a plugin to make transformations. Let's see. The user writes some code, and there is a hello world function which is not implemented. Then the compiler plugin intercepts that code and applies a transformation. When the code is compiled, includes all the changes, all the transformations. And finally, when the code is executed, the result will show the successful interception of the AST tree, abstract syntax tree. Let's see more things.
Okay, so we showed a very, very simple example of a Hello World plugin, but Arameta is far more than just writing simple plugins. Arameta is also a container that has the ability to bundle multiple plugins together. This is pretty cool because you have the ability to switch out plugins or combine however many you like. You can go crazy. Actually, I want to ask the audience a question. How many people in here has written a Gradle or a compiler plugin? Okay. Okay, cool. How many people have tried to write a compiler plugin? Okay, I mean, I've tried. Yeah, before Arameta, I've tried a couple times and failed miserably every time. But seriously, Arameta is going to change the game at how we write plugins, and I think it's totally okay if you've never done it before, because you will not believe how it looks. So you can wrap AST elements with transformable scopes, which may go back and forth between the models of Meta and PSI. And what we're looking at here is a meta extension plugin that 47 Degrees wrote specifically for our Arrow core library called the Comprehensions plugin. Within Meta, you have the ability to subscribe to multiple extension phases in the Kotlin compiler, including Arrow Meta's quote system. So a quote offers a high-level DSL that basically allows you the ability to transform the code that you're trying to grab, and you can also find like matching predicates for it. So what we're looking at is a dot-qualified expression, but we're not looking for any kind of dot-qualified expression. What we're concerned about is a dot-qualified expression that also happens to contain an FX block. What happens when we find such a thing? Right, so when we find such a dot-qualified expression that also happens to have an FX block, we have the ability to apply any kind of transformation to the underlying tree that is intercepted and made available by the Kotlin compiler. And what we're doing, for example, in this case, is we're taking the original declaration and we're replacing it with whatever two-flat map generates as a new declaration. And of course, if we're, as a coder, you probably are wondering, well, what is two-flat map? So we'll do the command-click figuratively. And this actually shows one of Arrow Meta's most important features called the template DSL. The template DSL is pretty great because it allows you to create these new declarations without necessarily having to preserve or manage the type information yourself. And this is great because basically in the past, we would be forced to work with strings during code generation. So when we're looking at this new declaration, you'll notice that we're actually able to directly access the properties of the AST elements without having to parse that information ourselves. And that's it. That's literally all there is. It's quite literally 4 steps. Unbelievable. And I wanted to show one more thing, because not only do we have a quote and template system, quote and template DSL, but we also have a compiler testing DSL available so that you're able to test your plugins. And I have to say that I've been lucky to try it out myself, and it was an incredibly enjoyable experience. And I'm blown away by the fact that we have the ability to do a couple things. So we worked with Thilo Schwartz compiler testing library in order to create a super friendly user DSL. And you have the ability to do things like, is what you're writing in your compiler compiling at all? Also, you have the ability to validate analysis. You probably want to make sure that what you think you're grabbing is what you are grabbing. And of course, you actually have the ability to upload your bytecode and check that it's working as intended. So there's a couple different places where you can check within the different phases of the Kotlin compiler to validate that what you're doing is working.
Thank you, Amanda. Okay, so let's see another example of plugin. Sometimes we need to have more than 2 values. For example, we need a value in case everything is working as okay and properly, and another value in case there is a failure. For example, let's think about result in Kotlin. With result in Kotlin, we can store in a variable a value of any type in case everything is working properly, or maybe we can store an exception in case of failure. Another related example is either from Arrow. With either, in the same way, we can have 2 different values, the right part and the left part. And with the right part, we store the value in case everything is working okay. And with the left part, we are storing the value in case there is a failure. And in this case, it's a value for, from the right part of the left part of any type. So what if we want to have more than 2 values? What if we want to have more than 2 choices? Or what if we don't have, or we don't want to have a special meaning for every single value? So with AeroMeta, we created a plugin to define or to be able to define union types. And let's see a very simple example. We have a variable, and that variable can have a value. It's an apple or an orange, okay? So sometimes that variable store an apple, and other times an orange. So with this plugin, we can write code in this way. We have a variable, an apple or orange, which is a union to, in which we specify that can store a value of a type apple or orange. So in the first line, we are assigning an apple, and it's OK. Then an orange, and it's OK as well. But maybe the most important thing is the security. In case we assign a value from another type, neither apple nor orange, for example, a strawberry, and we will get an error. OK, so in this way, with union 2, we don't have a special meaning, just 2 different values and no special meaning. But what if we want to have more than 2 values, 2 choices, for example, 3, 4? So the plugin also provides union 3, union 4, okay? And for all the features that we have seen until now, all you need to do to get them into your project is to use the AeroMeta Gradle plugin. But Amanda, what about the Intelli idea?
What about it? No, I'm joking. I know what's about it. So everything we've been talking about right up to this point has been compiler plugins. But AeroMeta is looking to bring more than just that. We're looking to bring an improved user experience right to the IDE. So let's take a look at an example. Earlier, if you were paying attention, we were talking about the comprehensions plugin. And what we're looking at right now is the IDE complement of the plugin. And you'll see that there's little icons to the side and some helpful messages for the user. And this is pretty significant for us because what's great about this comprehensions plugin and what you're looking at is that this actually applies to any kind of valid flat map data type. So we're talking about more than just Arrow IO. We're talking about Kotlin collection APIs. We're talking about RX Java. We're talking about any reactive things, anything with flat maps. So this can work across the board. Kind of a neat thing, but let's take a look at another example. So here we're looking at some programming that is focused on whether what you're programming is pure or impure. And you'll see that we have some custom messaging for that. But I think what's incredibly significant about this and what is significant for us at 47 is that we are so excited that we have the opportunity to bring functional programming to you, the developer, like right in your editor. You don't have to go to the website to like check for the documentation. We're really hoping that for us, we can bring more of an interactive experience for functional programming for folks.
Thank you. And now I have an important message for you.
Hey. Are you guys paying attention? Are you awake? Okay, okay, good. I just had to make sure. Okay, I'm sorry.
Thank you, Amanda. Now I think they are paying attention.
I think they're awake.
Perfect. So Arrow is a functional companion to the Kotlin standard library. And like Arrow, Arrow Meta is a functional companion to the Kotlin compiler. Both of them, Arrow and Arrow Meta, follow the same principle, which is any feature from Arrow, Arrow Meta, or any of the plugins, which is adopted by the Kotlin language, will be removed from Arrow. Arrow Meta is just a way to complement the Kotlin compiler and to open a window to create prototypes and to explore what's possible to do with it. Thank you for your attention. Thank you.
I have chills. This actually brings us kind of to our full story, especially in regards to keeps. Arrow Meta would have not been born had it been for the existence of Keep 87. And I hope that folks maybe start looking at Arrow Meta as a way to enhance the Keep process. And you know, maybe more than that, maybe you might be interested in writing a plugin for your own library, or maybe a library you really, really love, and there's a feature you wish it had, and no one really quite got to it yet. But I think there's so many different possibilities for it. And here's the thing, 47 degrees, we're really excited because we're literally on standby, and if you're interested in writing your own plugin, we're ready to help out. So, speaking of which, thank you so much to the Kotlin community. There was a whole lot of conversations to be had with the Arrow Meta Slack channel, the compiler channel, and the Lang proposal channel. We mostly reside in the Arrow Meta channel, so if you have any ideas or have any questions, I mean, literally pop up and we'll take some time to help. Also, we've been having kind of these like weekly ad hoc on demand, you know, Google Hangouts or something, and we love like telling people more about how the compiler works. We love telling people more about our Arrow Meta system, and it's been quite an amazing experience. So we've been doing that as people have been asking.
And thank you, 47 Degrees, for pushing and sponsoring the development of Arrow and Arrow Meta. And 47 Degrees is also sponsoring KotlinConf. We have a booth here, the number 8, so please be sure to stop by to say hello. And we will be very happy to answer questions from Arrow, Arrow Meta, or 47 Degrees.
Ah, yes, and of course, thank you to the people that made Kotlin and IntelliJ. Thank you, JetBrains, so much. JetBrains have been incredibly supportive with this whole process. They've been awesome, answering lots of questions we've had about the Kotlin compiler, giving suggestions, and we're just so thankful that we're in a community like this.
And thanks to all the people who are bootstrapping Arrow Meta and makes Arrow possible. More than 150 contributors from all over the world. And not only Amanda and me are here, but also more people from the community, as Raul Raja and Simon Bergan. They are here as well in order to answer questions as well with us. And say hello. And Arrow is an inclusive community where everybody is welcome. So join us.
Join us.
And last but not least,
thank you for sitting in this room and listening to us today. But also, keep insisting.
Yeah, and please remember to vote. Thank you.
Yeah. Thank you so much. Oh. Yeah. Oh. Oh, hello. Can you hear me? Can anyone hear me? Oh, okay. I think we have some time. Oh, we have some time for questions. What questions do folks have? Nope. Ah. Oh, there's one down here.
So did I understand this correctly? So error emitter is also possible, like to write compiler plugins which don't rely on Arrow, the library?
That's correct.
Okay, thank you.
Yes. Yes. To add a little more to that, there's another up there. To add a little more to that, we wrote error meta because we needed some special capabilities that were a little bit more advanced in the language, and we just like wrote these plugins to be added to error meta. But I mean, error meta can exist by itself. People can use the error meta DSL to write it for their own things. So even though they share maybe the same namesake, they exist as independent libraries, all under the Arrow umbrella.
Can you maybe tell me a bit about what was your experience like writing this and like interacting with the Kotlin compiler? Because I did try and I failed miserably, and I tried again and I failed miserably, and you know it went like that for like half a year. What was your best strategy for like fighting the Kotlin compiler and finding resources?
I cried angry tears like twice the first 2 weeks looking at it. Here's the thing, there's a lot going on with the Kotlin compiler. There's a whole, it's massive. So something to understand about the Kotlin compiler is that it contains, like I said, it's far more than just a compiler. So we're actually talking about adaptations for IntelliJ. We're talking about the Android extensions. I mean, literally everything is in there, and so many different people have worked on it. There's quite a bit of history on it, and you know, there's a lot of like shared Java API settings. So I think, like I said, the compiler channel has been pretty helpful. I know there's not a lot of documentation right now, but I think really the best way to look at the Kotlin compiler is with some sympathy and compassion and empathy, because you know, I heard this joke one time where it's like, you know, you should always code like someone's about to kick down your door, like who wrote this, right? But you know, it's a lot of hard work. The JetBrains people have always been super helpful giving historical context, and we're very, very lucky because we have folks at 47 that's been studying the compiler for a long time. And what I personally did to get some more understanding about it, because I didn't even know how compilers worked, I actually started going through academic readings and cross-referencing that with the IntelliJ platform STK cookbook, because they talk a lot about the code system that they have, and they might mention some parts of the compiler once in a while, but no context. So that's how that's been going. Yeah, I have a Kotlin compiler crash course, README on GitHub that people can probably look up or something. But there's a lot of good resources in there. Yeah.
First of all, thank you for the talk. Very interesting. I have a question regarding like JetBrains announced they're gonna change the compiler, so that's not very good news for you, I guess. What's your current approach if they're gonna change it? But I guess you have some APIs, like interfaces you were investigating, probably gonna be so different now, maybe easier, maybe trickier. So what's your expectation for this matter?
Yeah. We have a bot working with us, and they are doing that job. That bot, every day, is synchronized with the early version of Kotlin, so we can check if everything is working okay. And in case of failure, the bot creates an issue for us. And if everything is working and there is a new early version, so the bot creates a pull request for us. So
yeah, and I also want to add a little bit more to that. So when we're talking about the new compiler stuff with 1.4, a lot of that has to do with a lot of, you know, if we remember when we were talking about code generation, we were talking about ASM and IR. JetBrains has been leaning towards like going to IR, and we've been working on, so even though we have the ability to use either option, like we've been working heavily on the IR side, and between the keeping track of the constant changes in the early snapshots, like we're doing our best to keep up with it. So it's gonna be good. It's gonna be good.
I'd like to understand a bit more about IDEA integration, because you showed us an example, for example, for the union2 type, where you declared a union2 type, but you assigned not a union, what's inside the union. So I understand how you can create translation or code manipulation inside the compiler, because the compiler manipulates text, but how, for example, do you do to have the idea not showing an error when you are assigning the wrong type to a variable? So how does this IDEA integration works so that the tool can also understand the error meta plugin?
Oh, okay. So I believe you're asking, so we have the union, and what you're asking is, how do we know that the compiler plugin that we wrote will like react to the IDE side? Is that correct?
How does the IDE knows that there's a plugin and that this code will actually compile? Because it's not correct Kotlin, right? If you say val u of type union2 apple and strawberry, and then you later equals apple, then it's not union2 dot of, or what do I know? It's not the wrong. If there wasn't the compiler plugin, that wouldn't compile because the types aren't compatible. So I understand how you can transform the code inside the compiler, but what I don't understand is how do you talk to the IDE to make it know that this is correct code?
There is also a plugin for Intelli IDEA, but pass the microphone to...
So this is a part that I worked on, so it's probably better if I answer this. So what's happening is that metaprogramming in Kotlin is not as we see in other languages where it's just a structural and based on the tree. We do have access to all compiler phases, and that includes the Kotlin type checker. So subtype relationships in Kotlin, which is a language based on subtype polymorphism, they can be synthetic as well. You don't have to extend something to make it a subtype if you control the compiler. So the type checker provides an evidence path between two types, which basically breaks the need to have inheritance and allows for composition, where otherwise the Kotlin compiler would insert a typecast because they're not real subtypes of each other, that association you've just declared. We instead insert a type proof, which is a morphism, a function that takes you from one type to another. Type proofs can be inductive. So you can prove that you have a proof from A to B, from B to C, therefore you have A to C. And that allows for generic derivation at the type level and allows for the compiler to understand the graph of your dependencies and to create a system by which you have compile time dependency injection. And you don't need to rely to any runtime trickery like reflection or even refi types or any of that. So that kind of power, you can have it the moment the compiler has the notion, or you as a user can give the compiler proof that you can draw a line from a type to another. So in this case, we told the type checker that we said universally quantify for all A's or for all type arguments of A, whatever those are, whenever A is in the first argument of the union, then that is a subtype. So the assignment is valid. There's no need for constructors. There's no need for anything. Once the code generation phase comes through, that will be a typecast. Then we can replace that typecast for the proof, which is the function that takes you from that value of that type to the other. The IDE understands that because the IDE uses the Kotlin type checker to determine redlining. So that doesn't even require synthetic descriptors as mentioned before. Now, if you generate new declarations or new members, for example, if you expand a class and you add a new function to it with a compiler plugin, then you need the synthetic descriptors. And those IDEA automatically generates for you. Because the IDEA plugin that comes bundled with AeroMeta and auto installs itself is able to read the synthetic descriptors in real time as you type and provide you with the code completion that your tree transformations are producing. So that eliminates the problem that we have also for the longest time in the Scala community, where there is 3 libraries that are blessed: Cat, Simulacrum, and some other library, and then the Scala plugin includes the synthetic descriptors for those plugins. But all other libraries are forced to write IDEA plugins with hard-coded synthetic descriptors so that IDEA understands how to work. So that's like, that frustration is actually what led us to AeroMeta.
Yeah, so to add some like minor clarification to that, so when we're talking about compiler plugins, a lot of that is where, you know, like the logic of whatever you want is usually done there, and that side like usually has descriptors that are mapped to the nodes. And the reason why you need synthetic descriptors, like sure, we're just like, well, they need synthetic descriptors, but it keeps a lot of that same information, but you don't worry about, you know, clashing like concurrency issues, and that's why there are split versions between descriptors and synthetic descriptors. Yes, 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 yes. Are there any more? Okay. Okay, okay. We got a little time, just a couple minutes.
Hi. This may be also a question to Raquel, I'm not sure. I wanted to know what is the state of the Keep 87, the type classes for Kotlin as a language proposal. Is that still something that might happen? I'm going to let you answer that one.
Yeah, I did not check this morning, so.
No problem. We submitted Keep 87 about close to 2 years ago or a year and a half ago. So as we saw there, it has a lot of traction, which I completely understand how that is problematic to the Kotlin team, because it became a controversial feature, nonetheless, right? So no hard feelings there. We haven't had any real feedback from, like official feedback, though many JetBrains people, of course, have commented on it. I think in general there is a flaw with the Keep process, and the problem really is that the Keep process, it's more of a mailbox of suggestions, right? So there is no really community process or anything. You suggest something, it's cool, then goes through, but a lot of language features come through without keeps. And that's fine. I think it's okay in Kotlin too, because it's a language that is rapidly evolving, and we don't have time to like get caught up in politics of huge communities and people like that. So I think it's fine, and using metaprogramming and something like AeroMeta, it gives you something that is very powerful. All these features are opt-in, meaning that we are not enforcing these features in all code bases. And whenever you compile something with meta, the produced binaries are compatible elsewhere. You might not benefit from the syntax like we saw in the unions, where you can just swallow the value. You may have to call first or second to put it in the right place, as if you would do in vanilla Kotlin. But in whatever case, if, as Amanda and Raquel mentioned, if they do at some point decide to bring type classes or extension interfaces to the language, in whichever shape, not even as proposed in Keep 87, but whatever shape it's appropriate, then we are committed to remove it. Because all we're doing here is complementing and trying to push the boundaries of what's possible with Kotlin, so that new research and development keeps on moving forward. And some of these techniques like union types and type classes are just no-brainers, because they've been demonstrated that they work in languages even with subtyping for years. So this is something that we want, and we're just trying to be nice and make it happen in a way that does not affect or impact the evolution of the language.
Yeah.
Thank you.
All right, I think we're getting kicked out, but it's been really fun. Maybe if you guys have questions, like a lot of the original Arameta team were here, maybe we'll just step out. And of course, we have a booth at 47 Degrees where we can tell you a lot more about this stuff. Thank you so much.
Thank you.
Thank you.
Hi, folks. Thank you for coming. My name is Maxim Mazin, and I work at JetBrains since 2006. And until the last year, I was leading the UTrack team. UTrack is backend issue tracker by JetBrains, written almost all in Kotlin as well. But since this year, I'm a part of Space project. I'm software engineer there, and that's why I'm going to talk about Kotlin technologies we are using in Space and like how we use Kotlin to build this product. If you missed yesterday's announcement and still somehow end up here, Space is a new integrated team environment by JetBrains. It contains all parts your teams need to work and communicate and to deliver stuff. Are they developers or not? Doesn't matter. Still, everybody's welcome. And Space is full stack Kotlin. It means that we have different environments where Space is running. It is JVM on server side. It is IDE plugin. It is Android and iOS applications. And we have Kotlin.js framework, web front end that we use to build our web application, and we use it as well for our Electron application right now. We reuse a lot of code using Kotlin, and thanks to Kotlin multi-platform, it enables us to do it. But we are using a pragmatic approach to multi-platform. Normally, when you have, say, JVM backend and JavaScript front end, you share some data. Maybe you generate some data model classes for JavaScript. Maybe you generate some RPC methods, but that's it. With Kotlin, we also are able to reuse view models that are going to the server side, fetching data, layout it somehow in memory, and then make accessible for UI components to be drawn. We reuse common libraries, utilities, and data models sure as well. But we don't reuse UI components. We think that like every platform has its own infrastructure, and you want your application to look native on iOS, and you can hardly achieve it using frameworks that enable you to write one UI code and use it everywhere. So we don't reuse this. And storage available on different devices and in different client environments are also different, with specific requirements to the amount of data you can store and how you can store. So the storage part is also not reused, but pretty big part of code is actually reused. It enables us to create features quite fast. So say we want to reuse this data class. It's some data class for a holiday. It has name and it has date. And there is, in Kotlin standard library, there is string type, but unfortunately, there is still no local date. So we can do something with it. We can declare it using the Kotlin MPP. We can declare local date without any fields. And we can use actual keyword to define the particular implementation for the platform using type ls. So using this, normally for each platform you have some kind of implementation of such things as date times, so you can reuse the vast majority of functionality from there. Local date is not just a presentation of data, but also you need some, with it you need some operations, so we can use expect actual functions here to implement this. You can see that in different languages this looks pretty different, but your API, that is your libraries and your models that you are using in your application, they don't need to cope with it. They can just use these basic methods declared in common code. Next, I'm going to talk a little bit about frameworks that we are using to build Space. And first one will be Exposed. Exposed is an open source framework. You can use it. it provides you with some functions for type-safe SQL writing and for object relational mapping, like Hibernate for Java. You can use Exposed for Kotlin. In Exposed, you define tables like this. This is pretty similar to what you would have in SQL, defining table, but you have reference consistency if you do it this way. So after you declared the table, like in Kotlin, you can then reference its columns in your Kotlin code without any stringly typed stuff. To create database, you actually connect to it, and then you can use your schema defined in several tables. You like here in user table, you can actually upload this SQL, initialize this SQL schema. The cool thing about Exposed that it can track the changes in your model, and after each restart, it applies the migration, so it adds required columns and missing tables and so on. For sure, there are some cases that we cannot cover this way, so in that case, you need to write code manually, like migrating, adding some default values for that. To insert data in table, you use something pretty similar to your SQL statement, but referring columns in Kotlin. To query database, you use syntax like that. It's not only the way you can interact with database from Exposed, you can also define entities. You define a class. This is a part of the object relational mapping. You can define a class. You can link it to some table. You should define its companion object to be an e-factory that will provide you with a number of methods like create new entity, query all entities of that type, and so on. And then, thanks to property delegation in Kotlin, you can define different properties, mapping them to columns in a table. So after that, creation of new entities in a table becomes more object-oriented. So you just use this factory method, initialize fields, and that's it. Searching is pretty the same. So you can query, you can interact with tables like with just queries of entities. Next part of that drives our application is Ktor. It's open source as well. You can use it like we do. It is both server and client, so you can define your server side using Ktor. It's one-day cell, and also you can use multi-platform client, so you don't need to bother how exactly you need to communicate with HTTP from JavaScript or JVM or other places. So this part is multi-platform, and it helps us to write our clients. And Ktor is completely asynchronous. So when you define some endpoint on server side, you define it in a synchronous way. It's not blocking. When you call something from the client side, it is also asynchronous, so it's also not blocking. You define and run server right from code. You don't need to bother to create some servlet container, deploy there your WAR files or whatever. You just create a server, initialize it, and then you start it. That's it. Ktor supports a number of features for authentication, for routing, for different stuff. Yeah. But almost, I'm pretty sure that if you use Ktor, you will use routing because you need to define like how your application handles different endpoints. So you define routing like this. Then inside it, you define different methods. And then inside the method, you can, this lambda that is passed to the get method is suspended function. So you can have your asynchronous code. You can go to database, in non-blocking manner, or you can read from somewhere else, or write. The cool thing that Ktor consists of different modules, so you can define part of routing like this here, you can define another part of routing this way in another place, and you can build your application from different parts, and it actually enables us to create plugins, where you can create plugin, and it provides some additional endpoints without any additional effort. Yeah. Ktor supports WebSockets. It looks like this. So you just assign some lambda to a URL, and there is a socket. The cool thing here about Kotlin is because of coroutines, you can have code like this, right? Code like this, where you need to define an endpoint, and you need to say what happens on open, on message, and so on. You can have it like this, where this on connect happens at the beginning on open. At the beginning of this section, then on message happens every time you read next frame from the incoming source. On close is an exception, and on error is also an exception. So you don't have this split it in several parts, pieces of codes that should interact and pass data to each other. You have linear flow of code. That's because of coroutines. We're unfortunately, or fortunately, there is no still support for remote procedure call in Kotlin X serialization, but as far as I know, there is some plans. So we had to implement our own WebSocket RPC. You can define some class like that. Then we define interface, which has all its methods suspended, so it's asynchronous. We wrote some generator that generates proxy to be used on the client side, and you see that this proxy accepts API service. It's actually just a data class that contains information about the endpoint where the space server lives and some authentication. And thanks to extension functions in Kotlin, we can say that our users is an extension for API service. So after that, when we use it from the calling side, we can say like API.users, like this API contains all the data. It's just a simple trick, I guess everybody of us use every time. And once again, because of this is asynchronous suspend function, you can do things like that. You don't need to handle some on ready or other events. You can show loader, you can make your call, you can hide loader. Code becomes linear and simple as well. To make it all working, we need to implement this interface on the server side. So for instance, in Space we are doing like all the business logic more or less here in this place. So we check permissions, we open transaction, create a new user, and return it. I do know all the controversy about this implementation delegation. By the way, how many people are hating implementation delegation here? Oh, not too many, okay, that's fine. People on the internet are much more angry than in the audience. Yeah, but this feature helps us to put all these permissions and transaction methods into context and access them without having a prefix like context.permissions or context.transaction. This is just a nice way. It's shortened code a little bit. And now the cool thing. Having everything written in Kotlin, you can do things like following. You have some UI code where you have the call to create new user. You can navigate from there. You can navigate to the definition of this method. From there, you can navigate to implementation of this method, then to entity declaration, and then to database. So you can you can navigate and you have reference consistency for your entire application. So you can get from where you are, you can get to any part of the application, and there is no barrier. So if you are a front-end developer, you still can go and check like what is the limit for the number of characters in this column. It's not like you need to know where the handler for that method on the server or something like that. And vice versa, if you say you see some table that you think is not used anymore, you can search for usages and you can find all usages back to the very front end to understand like, is it actually used or is it some piece of dead code? So reference consistency is a cool thing that you get when you're using Kotlin full stack. We are not only use these interfaces ourselves, but we also use them to define HTTP API. We are pretty sure that it is important to use the same methods or to give the same methods that we use ourselves to create front end, to give them to end users, because otherwise, if you don't do it, if we have HTTP API somewhere separately, we will end up in the situation where we are adding some functionality that is in some gray area that is not usable by our customers, and it's not cool. So technically we can have some functionality that is in gray area if we like do not mark some of these methods with the annotation, but we do. From that declaration we can generate playground. So you can get into space, you can get there to the administrator HTTP API playground, and you can trigger different methods right from the UI. It's quite handy. For sure, we generate Kotlin client. It's not in the Maven repository yet, I mean public Maven repository yet, but it will happen soon. We support partial requests here, you know, like GraphQL and all these things. And if for some reason you decided not to use Kotlin, we generate our Swagger OpenAPI JSON, also known as Swagger. So you can take it, stick into code generator, and get code generated library from Swagger code generated library. Next, I'm going to talk a little bit about our front-end technologies. First of all, it's Kotlin React. Kotlin React is open source, available at GitHub. Actually, it's available on GitHub as a part of the Kotlin wrappers. It's a repository with different JavaScript, Kotlin JavaScript wrappers. So it is Kotlin DSL for React, and it looks like that. So in some, it gives, because it's Kotlin, it provides you with some additional features you don't have if you use it in JavaScript. For instance, you define properties like an interface, and it is strictly typed. And if you are using React.js, you can have some type checking, but this type checking happens on runtime, and you need to bother passing property types that are a little bit decoupled from main code. So having it strictly typed is nice. You inherit from R component, and then you write the body of your component in Kotlin XHTML. Kotlin XHTML is a Kotlin common library, so you can use it on different platforms, and we'll get back to it a bit later. When you want to use some component, you need to embed it, you need to put it to your markup, and you do it like this. This doesn't look nice, so you can define nicer method, and what actually happens when you define components, you can create methods like that, and after that, you can use this XUser component right the way you would use any other markup methods, which is pretty handy. Next thing is style component. There is a Kotlin wrapper for style component. It's Kotlin DSL, but for CSS now. It provides you with the type-safe CSS declarations. So the cool thing, you define your component, and you put your CSS code right into this component, and not like somewhere else. So you can maintain your code together, together with logic and together with markup. You can also define your style somewhere else. In that case, In that case, this generated code won't be, will have some nicer name, like if you generate this style here, you can reference it. You can reference it like that, and it will embed CSS. The good thing that if you have this CSS inlined, it won't generate you actually inline CSS, like garbaging your entire generated HTML, but it rather creates a dynamic CSS class and then reference it. Because of that, you can do different mixtures like that. So you can reference user styles plugin. It will be inserted as a class. And you can also, as it's Kotlin logic, you can also put this logic right here. You can check if user is admin, for instance. And then, in that case, you can add class for its color. We have email notifications, and email notifications is something specific. Normally, you write email notifications some framework like FreeMarker, but we do it right in Kotlin, and we are using Kotlin X HTML once again, and we are using the same markup, the markup that looks the same as our front-end markup, but with some additional features. When we generate it, as you might know, you cannot use classes, and you are really limited in CSS attributes when you are rendering emails. So we can handle it, and we can embed these classes and styles. We can embed right into generated tag elements of the email. And the syntax is the same. Test for sure we are writing in Kotlin as well. We are using JUnit for like API tests. We use this trick. How many of you are using this trick for tests? Very nice, cool. We use this trick to have nicer names for tests. For other places, it doesn't work that well. And we are using assert_k to have nice assertions. It enables you to, if something fails, it doesn't give you something like John Doe is not equal to Jane Doe. It explains you a little bit what was going on there. Web client tests, we are writing also in Kotlin. We don't have too many of them. We are using them to use to test our components. We are using Enzyme underneath, and we have this sort of Kotlin wrapper around it to check stuff when we are dealing with components. And the last thing important here, I guess, is the WebDriver tests. WebDriver tests are also in Kotlin and also using JUnit for definition of the pages and the content of the page we are testing. We are using HTML elements. It's a library by Yandex. Quite nice. It enables you to define the structure of your page, some behavior on that page, and then your Selenium or WebDriver test doesn't look like a complete mess. It looks like you are going here and there and clicking stuff, and not like you are creating some drivers, wrappers, and so on. For reports for the WebDriver test, we're using Allure. It allows you to split your test into several steps, and after you have the test run, you get this nice report. You can have screenshots there. You can have different stages. So for UI tests, it's really handy to find out what went wrong. And when the test fails, it also attaches screenshots, so we can see how did it look and why your code didn't find some button there or something like that. We are not using Kotlin ourselves. We force our users to use it as well. We are using Kotlin for as a language for automation scripts. So this is how code for running a Gradle build may look like. So you define a job. It's a unit of work for our automation. You say that you want to run this job in a Gradle container. in a Gradle Docker container, and then you define the script. Like this is Lambda that is actually, this is imperative code you can use, and you can define what you want, how you want to run it. So you can have some logic here, like checking if the current branch you are building is release. You can add some parameters for the Gradle script, and it will change the behavior. This, like all these technologies, they are all in Kotlin, and because we are using Kotlin everywhere, we can have full-stack Kotlin developers. But people cannot be that sure, like when they are creating some style CSS and code and front end, and at the same time be experts in iOS development and tweaking S3 or something like that. That's why we're having this separation in team. Like there are people who are working more on the platform-related things, like on backend platform or front-end platform or iOS platform, and there are people who are using these platforms to create features. This combination of specialities enables us to deliver features pretty fast. So here are the libraries I was talking about and mentioned during my talk. Thank you, and remember to vote. Oh, yeah.
Thanks for the talk. So my question would be, there are so many testing libraries for Kotlin written in Kotlin and so on. So have you considered using something else than just JUnit?
Because it was already there. Like, and yeah, I was kind of expecting this question. We just started to using JUnit, and we didn't think like like things like spec or something can deliver immediate preferences for bonuses for us. So that's why. But I guess we have some spec tests as well. Yeah.
Thank you for your talk. I would like to know what is the size of the team?
Say again?
The current size of the team working on space.
Last week we were 51, and like a year before, when I joined, we were like 25. So we are growing pretty fast. This 51, including everybody, including designers, including QA team and marketing and tech writers.
Hi. Do you know how many % of code is shared, approx?
It's an interesting question. I guess server-side code is not too much shared just because it is like server-side. It does some specific logic. But for client code, my approximation would be like about 60 to 70%. And especially it helps in the complex parts like chat subsystem. It is very complex matter, but we are using the same virtual model, view model for chats. So this complexity of the chats doesn't get into each platform. So you can handle it one time.
Hi, up here. As far as I can understand, Space has some similarities with, for example, Team City. Were you able to reuse code from other projects, or is it entirely from scratch? Thank you.
I would say that we are writing it from scratch, but it won't be too much true because many people from different products came to us. They came with their expertise, and they came with some pieces of code sometimes. Like, so we are not like extracting a library and then reusing this library. It's more like we are just taking some code. If it's not written in Kotlin, we translate it into Kotlin, and that's it.
Hi, what happened on mobile?
What happened?
Mobile. What, did you use MPP or?
Oh, yeah. It's, yeah, thanks you mentioned. Heidi said that there will be a lot of talks about mobile platforms. So I cannot just not talk about how we are using Kotlin native and Kotlin for Android, but we are using Kotlin native with a little bit of Swift there for iOS, but mostly Kotlin.
Hi. I'm not sure I've understood about the REST API. We are talking that this is something which is not open source yet, the way you export the REST API and you consume the REST API.
REST API is there. I mean, it is open source, but the library we generate for it, the Kotlin one, we haven't yet deployed to Maven, just because announcement and deployment to Maven. Like,
okay. Okay. Didn't fit. It's expected to be coming soon. The open source version of the API.
Sorry?
It's expected to be coming soon.
Yes, sure, like this next week, I'm pretty sure.
Thank you very much. I had a question about how you work and how you manage to work on a big code base like this. Do you have everything in the same Git repository, or do you split repositories, and how does it affect your workflows?
We store everything in one repository inside space. So hey, doc, forget it. It's fine. I mean, this project is not that old to bring problems here, and it's not too often when we break stuff.
You mentioned you were able to have like global project scope, find usages and stuff like that. Does that mean it's one big IntelliJ project, or just one?
Yeah, one huge IntelliJ project.
Oh, wow.
Yeah, but we are trying to put functionality into plugins. So when you change something in platform part of this beast, it may affect your performance, like to rebuild all things. But if you are tuning some issues or version control, something like that, it's fine. You just rebuild this small part, and it works like a charm.
Team City also has Kotlin DSL for creating builds, and I'm curious if there's some kind of effort in keeping these similar, or that the evolution goes towards the same direction.
Almost like you say, but the opposite, because you know, this opportunity to build this new DSL for guys from Team City, it was an opportunity to create it like the second time better way. And the continuous integration in Team City is a little bit different comparing to what we have. So we have more like jobs, and you combine them in pipelines and so on. And for Team City, you have build configuration that depend on each other, which is like more or less this like equivalent, but it doesn't feel the same. So you have a little bit different tasks in DSL here and there.
Thank you.
Thank you for your talk. Could you explain a bit, do you have the same set of features for all available for all platforms at the same time, or sometimes you have something in web which is not ported to
we
Android?
We deliberately decided not to do it. Like, you don't need administration. Like, we decided that you don't need administration tools on your mobile, and you more like need some chat, team directory. You want to check where who sits. So we are not putting everything to each platform, but if we see that something should be shared, we share. Yeah.
No, it's more like if you want to make this feature available for all platforms, do you publish them at the same time, or there are some gaps when some feature is available for web, but then they become available for Android or for mobile, or?
There is some gap. There is some gap, but we are doing this continuous delivery thing, so we deploy often, and we publish our applications often as well.
Sorry for taking too much time. And if you can, could you go a bit deeper into databases that you use? Because you have, if you can, of course, because you have quite different things you provide messages, blog posts, calendar events. Everything is completely different and have different behavior.
I can say about the current state, because we moved through lots of stages changing technologies. The current state is we store data in SQL database. We use Redis for event bus. And when I'm talking about event bus, it's more like when something changed in database, you need to notify others, like the new user appeared. So this kind of event bus. We are multi-node, so we need some distributed event bus. We using Elasticsearch for indices, and we use it to index repositories as well. Like we have text indices for full text search, and we have repository indices stored in Elasticsearch. We have our own implementation of the Git storage. So we store data on S3, and we store this, it's not a schema, I forgot the name for Git. They have, like we store the schema, the tree information in a SQL database.
So I'm up here. I'm wondering, when you have this big project, how long time does it run to run your continuous integration tests? Because I was seeing some of the tests took like 20 seconds, and I guess that was one of a couple of hundreds. So what's the feedback loop for the developer making changes?
Well, you know, we are using, I mean, to run tests, it takes about an hour to run all UI and not UI tests. They are running in parallel. But recently we started to use such a technique like merge robot. It works like the following: like you are doing your stuff in a feature branch, if you can break something, and when you decide that you're almost done, you can press like some button in TeamCity, and it merges the trunk, the master branch, to your branch, run all the tests, and if everything is fine, tries to push it back, like updates from master again. So it's like it's not that big problem that the tests are running too long. But for sure, it will be nice if they will run way faster.
I was curious what your biggest pain point is at the moment. Like, what are the things that you're most anxious to solve in terms of how you're doing development?
Our performance of intelligent integration with Gradle, and that's really good because, like, we have. Since I joined the project, it improved like 3 times. So I guess this works. This helps. So yeah. But performance, yeah, I guess.
Thank you.
And do you use test-driven development for this project, especially for front-end?
What development?
Test-driven development.
No, I cannot say that. We are trying to write tests for things we are creating, and especially components, but I cannot say that it's test-driven because, like, first we write stuff, then we test it.
Anyone else?
Okay, thank you, guys. Yeah, thank you.
Okay, thank you everyone for coming. This is Embedded NoSQL Data Persistence Everywhere. I know it's been a long 2 days, intensive 2 days, so I'll try to keep you awake. My name is Salomon BRYS. This is at the bottom the link to my presentation. By the way, the presentation is written entirely in Kotlin React. I'm actually running IntelliJ, doing the server thing, so let's hope it doesn't break. So, quickly, so we can be done with it, I created a company called Coding Coders. We specialize in Kotlin in Europe. We provide training services for Kotlin, Kotlin multi-platform, Kotlin native, and everything's Kotlin related. So if you need consultancy on training, please feel free to contact us. That's the corporate part. The other side of the coin is the open source part, and that's the coding framework. The coding framework is a framework of libraries that aims to provide a set of high-level components that work everywhere Kotlin compiles. So the goal of the framework is to facilitate high-level application development on Android, iOS, the web server, and desktop. Today, we'll be talking about a library that is focused on mobile and desktop. So we'll be talking especially on Android and iOS. And yes, we do consider the web to be a mobile platform, and eventually the library that I'm about to talk to will be compatible to the web, but under no circumstances should you use it on server. It is, as the title suggests, an embedded database. It is not suited for server, and it will not work with performance you come to expect from a server, so please don't use this on server. So let's go back to the title of this talk, Embedded NoSQL Data Persistence Everywhere. I feel that there's a keyword that's staring at us in the face and that you would want me to explain to you what it is doing there. And of course, that keyword is NoSQL. But before I go ahead and explain to you, spoiler alert, why I think that NoSQL is the way to go for a mobile embedded database, I need to address SQL. So let's talk about SQLite. You start with your model, a simple data class here, for example, a user with a UID, a first name, a last name, and an address. It may or may not have an address, who knows. So once you have declared your model, your business model, then in SQLite you need to redeclare it in another language, namely the SQL language. And you have to declare each of its primitives. Then once you have defined its structure, you need to handle database creation. Because once you've opened a database that didn't exist, you can't interact with it. You need first to inform it of your model schema. Once you've done that, you need to handle the way you're going to put data inside your database. Essentially, you need to manually spread your data into primitives in order to put them into SQLite columns. And then, of course, you need to do the opposite. You need to create an ORM so that you can put the binary data, the primitives data that come from SQLite into your model. And then after that, you need to write how you're going to query your database by writing your query inside another language. Again, this SQL language. And then you get the gist. You need to do a lot of things. Essentially, you need to maintain an interoperability layer between your database and your model, your business logic. But the only thing that has value in all that code is actually your models. Everything else do not have business value. It's only there so you can handle how you're going to put and read data into that database. So this leads me to the following conclusion. Most of the time, in mobile or end-user applications, SQL is not needed for embedded data management. So before everybody on YouTube is going to flame me, I want to emphasize that this is an opinion. This is my opinion. This is how I feel. I personally don't like maintaining all that code, interoperability code between SQLite and my application. But of course, experience and affinity and a lot of things comes into play when you choose your technology. So, of course, this is my view. Please don't take it as yours unless you agree with me. So, let's get back to the only thing that has value, business value, our model. If you want to open a database, it should be as simple as one line. I open the database. Because if it exists or not is not the issue. I just want to open the database. If you want to insert into the database, then it should be a simple put operation. And it's as simple as that. Just create your model and put it inside the database. If you want to query the database, get a model from the database, then you should get its key. Whether you got it from a put operation or you recreate it from its ID, you create a key, and then you query the database for the model associated with this key. And if you want to query the database, then you should use the same language that you are using when you are developing your logic. You should use a simple Kotlin DSL. So it should be as simple as that. But of course, nothing is always perfect, and you need to define an ID. That's because I told you you can recreate a key from a model ID, so each document in a NoSQL document-based database need to have an ID, so you can use the @ID annotation. And you need to define its indices. So if there are index, then you need to define them with the annotations, and just like that, you have a functioning model inside the database. So, oh, and also, almost forgot, you may or may not have an address, and an address may be shared between multiple users, so instead of storing the address in the document, you need to store its key so that you can refer to it in a one-end relationship. So, I've just told you about the coding framework. Well, the new addition to the coding framework, the library that I'm here to announce, is CodeinDB, the embedded NoSQL database that's compatible with Android and iOS, and works, of course, on top of Kotlin multi-platform, which means that it works on Kotlin JVM and Kotlin Android, and it works on Kotlin native with the exact same API. With the exact same code, you can have a functioning database and deploy it everywhere. So, before I show you the API, I feel it's important that you understand how it works, because when you understand how something works, you can easily understand how to use it. The data storage engine that this database uses is Google Level DB. It's a C++ data storage key value engine. On top of that, we have developed 2 layers of interoperability, because Kotlin JVM uses JNI, but JNI is not compatible with Kotlin native, right? It's Kotlin native interop, so we developed 2 layers of interoperability to be able to use Google Level DB from Kotlin, whether we're on Kotlin JVM or Kotlin native. The thing is, these 2 layers of interoperability both expose the exact same interface, so on top of that, there's the data layer. The data layer is responsible for managing data from and to the database. On top of the data layer, there's the model layer. And the role of the model layer is to transform data from and to raw data from the database and to your Kotlin model. And of course, it does that with the help of serialization library. Currently, the library is compatible with 2 serialization library. You can use Cryo if you're targeting JVM or Android only, and if you're doing multi-platform, then the only engine that works is Kotlin X serialization. Then on top of that, there's a cache. It's a very important piece of layer, so I'll get back to it. And then on top of that, there's the API. The API layer is essentially a facade which allows your applications to use the database. The beauty of this layered architecture is that you can insert your own layer once you understand how it works. So there are two ways you can mess things up in this layered architecture. You can write a data middleware that will be inserted here in the layer, and you can change and access raw data, and you can add a model middleware which accesses Kotlin objects. And in fact, the cache is a model middleware. It's the first model middleware that's loaded, and then you can add your own model middleware. The cache enables tremendous optimization, because if you query multiple times, or if you put an object and then query it later, then it won't be deserialized, it won't be accessed from the disk, it's in the cache, you'll get the same model. But because the cache exists, we need to make a contract. In our new relationship, we need to add boundaries. And that first boundary is datum immutability. That comes from functional programming, so if you're doing functional programming, you won't have problem with that, but with datum immutability comes the insurance of no data races. Let me explain that. Let's say you have a data class, a simple user class with a UID and a name, and the problem here is that the name is actually a var, not a val, so the class is mutable. You get an entity, a model from the database, you mutate it, you put it back into the database, nothing should go wrong. Well, actually, you just created a potential data race. And that's because if you access the same data in another thread, then this will happen. You will see, because there's a cache, when you access the data, the cache intercepts your query and then immediately returns the object without querying the database. But if you mutate the object that the cache gave you, then in another thread, when you access that same object, you will see this modification. In essence, you have desynchronized from the database and the model. You will get a model that do not represent the actual data that is in the database. So please, don't use mutable data. Instead, simply use immutable data. Each time you want to modify it, make a copy, put this copy back into the database, and then you'll be ensured that you won't have any data race. So this contract is datum immutability. By the way, some time ago, I wrote an article called Designing a Kotlin Memory Safe Mode. It advocated about having const classes or having immutability being enforced in some classes on the compiler. I wrote this article when I was thinking about the Kotlin native memory model, but this is yet another example, yet another use case of why compile time immutability should be a good addition to the language. So, you know, if any JetBrainers is looking, you never know. So, you can open a database really easily, but that's the default behavior. Oftentimes, you just need the default behavior, but it's called the default behavior because you should be able to modify the behavior. In CodingDB, a lot of functions actually take a vararg last argument that allow you to pass a number of options. Options like, I want to disable snappy compression. The database automatically compresses your data using a very fast algorithm called Snappy, also developed by Google. But if you don't want it, you can disable it. Or maybe you want to enable paranoid checks because, you know, you're paranoid. Or maybe you want to change the open policy. By default, the database will open or create if it doesn't exist. By setting the open policy to open only, it will open if it exists and fail if it doesn't. You can, for example, disable the cache because there are some use cases where the cache is unnecessary. When you put a lot of data and never query it back, or when you're sure that you will access every data only once, then the database essentially maintains a cache that you will never use, so you could disable it should you want to, or you could simply define its maximum size. So you can pass a lot of option objects to the method and configure your database. So how does an object gets put into the database? How does it work? Well, first of all, of course, the object is serialized into binary data. And that's the role of the serializer. We all know what a serializer is, so let's move on. But that's not the only thing that's needed by the database. It also needs metadata. Metadata are things like its type, which will define the collection it will be sorted into, its ID, which is mandatory, and maybe one or more indices. And that's the role of the metadata extractor. All of that is handled by the model layer. Then, of course, everything, this binary data and this metadata, is put into the database, and that's the role of the data layer. Finally, of course, you can get an object from the database by getting its binary data back and deserializing it to an object. I want to take 2 seconds to talk about these two tools, the serializer and the metadata extractor. They are deeply important, but they work using reflection. And we all know that Kotlin native and Kotlin JS, by the way, do not support reflection. So how can it work on Kotlin native? Well, that's where I need to confess that I lied to you. It don't work on Kotlin native as is. You need to add a bunch of things if you are going to target Kotlin multi-platform, iOS, and therefore Kotlin native. First of all, you need to use the Kotlin X serialization library, and this library needs that every model that will be serialized or deserialized to be annotated with the @serializable annotation. Then you need to explicitly give the serializer to the database, and then inside this configuration object, you need to register every serializer that is going to be used by the database. That's because there's no reflection, so there are no other way currently to do that. Then, how does it work for ID and indices? Well, it don't work with annotations because there's no reflection, so we can't see these annotations at runtime. Instead, you need to have your model extend the metadata interface, provide the ID, and maybe provide the index. Now, this is one way of doing it. You can also provide your own metadata extractor, especially if you want to put into the database some model that is not handled by you, so you cannot have it extend metadata. So you can create your own metadata extractor, and it will be passed the model, and then it will extract the data manually. But this is the simplest way to do that. Of course, all of that jazz will become obsolete once compiler plugins are a real thing. And by a real thing, I mean not magic. Once it has an API and that we can safely create them, then of course we will align to that, and you will be able to go back to the annotations. Okay, so let's see a bit how you query the database. The simplest operation is just get. So you get the ID, the key, sorry, from the ID, and then you query the database with the given key. Maybe you want to find all user. Well, it's a Kotlin DSL. It's as simple as that. Maybe you want to find all user ordered by an index. So an index is used to query, but it's also used to order. And maybe you want to query by index. You want all the those, so it's as simple as that. You can, of course, add options. So things like you want to verify the checksum from the database. You can skip the cache entirely, which will remove the data from the cache if it exists. Or you can refresh the model from the database if you wish so. And, of course, you can define a specific serializer specific for the model that you are going to get back from this query. Okay, so let's get back to our model. This is a model that's compatible with Kotlin multi-platform, so you can use it on Android and on iOS. And let's say we want to add a new field. We want to add the birth date. Well, we want to be able to search and order by date, so we can add a birth index. And what I want to show you with this birth index is that CodinDB actually supports composite indices. That's an index that can have multiple values. Here, the index have three values, the year, the month, the day. So it will also define when you order by birth, it will be ordered first by year, then by month, then by day. Of course, the order is important. So, if I want to search everyone that was born the same year as I did, I can query by the first value of the composite index, the first and the second, or the first and the second and the third. If you have a composite index, you can search by just the first value or the first n values. That's the power of composite indices. So what if I want to search everybody who share my last name? Well, I could have an index, but the thing is, index can be composite, but ID can also be composite. In essence, the ID is the mandatory index. There's also at least one index, it's the ID, and that index can be composite. But it needs also to be unique. So that's why I'm leaving the UID value, because with that, I ensure that if there's someone with the same name and first name and last name as me, we will still be two separate documents. And with that, I can leave an index and have one index less, and I can directly search by ID with composite IDs. So this is very useful, and you should definitely use it, but you should get very careful because people actually get married. Who does that, right? So we need to pass another contract. We need to put another boundary into our relationship. I feel like it's in every relationship, and it shouldn't be said, but let's say it's nonetheless, ID defines document. If you change the ID, you'll change the document. Let's say you put into the database a simple document, ID1 named John, it will create the document. Then let's say you get it from the database and you change its name, well, it will change the name into the document. Let's say you get it from the database and you change its ID and its name, then it won't change it in the database, it will actually insert another document because you change its ID. So if you use the same key, it will return the same document. ID defines document. You change the ID, you change the document. It feels logic, but it needs to be said. By the way, the database also supports batches and snapshots. A snapshot ensures that the queried data set reflects the state it was when created, and a batch modifies the database atomically. Therefore, a snapshot can never reflect part of a batch modification. In essence, it's not transaction, it's almost transaction, but you can have atomicity using batches and snapshots. So you write your application, you write your business logic, and, well, you make a network request. This network request fetches data, and once it has data, it puts this data inside the database. Classic. But, of course, the business needs to be informed, so the network request also gives the data back to the business. Not a good idea, right? But we'll get to it. But before that, we'll get even more messy. Let's say you have a network service, something that listens, I don't know, to a WebSocket or maybe to push notifications. And when this network service gets data, it needs, of course, to push it back to the business and to the database. And that's a lot of errors. So let's use universal data flow, one source of truth, and all that modern things. And the usual stuff that developers do is add an event bus. And now that we have an event bus, every data should pass through this event bus, and then we have unidirectional data flows so that the network request and the network service both inform the event bus, and that's the role of the event bus to push data back to the database and to the business. However, that's one arrow too many, and I think you see where this is going. The database is actually the event bus. The database supports reaction and listeners. You want to take? Go ahead. Okay, so how does it work? Well, it's, as ever, a very simple Kotlin DSL. You register your listener. You want to register on put and on delete. Well, simply register did put and did delete and update your view accordingly. Of course, you can get a subscription and close that subscription. That's a difficult word. Close that subscription once you don't need it anymore, so that, of course, you don't leak the registration and everything it captures. That's local reaction, but that's not the only kind of reaction you may want to add to the database. You can also register before a put with will put, and that allows you to implement verification checks. So, for example, here I require that the first name is not empty. So if it's empty, require is a Kotlin function that will throw an exception, and then the put will be prevented, and then you'll have an error, and then you'll be able to yell at whoever did this mistake. You can, of course, for example, register a delete global listener, so that, for example, when a user is deleted, you also delete all of its pictures. That's another way you can do transactional work. So that's global reaction, and that's the other kind of reactivity you can add to this database. However, it's missing a part, and the question is, how do you get context from these listeners? Let's say, for example, that you want to put a listener and you want to react, but show a notification, but only if it came from the network. You know, if it is a message that I've just inputted, I don't know, then you don't want to show a notification, but it comes from the network, then you want to show a notification. How do you get context in listeners? First, you declare a class, and that class needs to inherit from options right. Making this class an option, so you can create your own options. And once you have created it, because it is an option, you can access it from the listener. You can access all the options and then get only the options that you want. And because it is an option, then of course you modify the if, and then because it's an option, then you can pass it as an option to the put method. So this option paradigm allows you to create and pass your own options, and if you create your own layers inside the database, or if you have your own listeners and middlewares and whatnot, you can always pass them information from the put side to the layer or the listener via this options mechanism. So we're not that far from the end of the talk, and I want you to be happy, so let's see some happy faces. This is Jane, and Jane is married with John, and John and Jane have 2 children, Jill and Jack. Yes, I did do a lot of research to find those names, but they're all smiling, so let's be happy. So you want to reflect that in your database. You create a class person with a name. Let's say the name is the ID because we want to keep things simple, stupid. Then we declare a class child that extends person, and you know, a child is actually a person, but a child also have parents. So it inherits person and have multiple, who knows, parents. So let's insert the parents, Jane and John, and then we'll insert the kids, Jack and Jill. and then we'll query for all persons. And maybe you've seen this coming, we'll actually get only Jane and John, because we created two different collections of document, person and child. By default, the collection the document will be put into is its type. If we don't want it to be its type, then we need to add the @polymorphic annotation, which allows the database to know that children are actually person, and to put them all inside the same collection. But once again, this should be as simple as that, but it's an annotation. Annotations don't work in Kotlin native, so there has to be another way, and here it is. When you open the database, one of the options you can pass to it is a type table. A type table allows polymorphism and other things that we'll discuss later, like in the next slide, I think, well, enables polymorphism. So if you want to declare that a child should be a person, first you declare person as a root, a collection, and then you can add all of its subclasses so that you can ensure that all children will be put inside the person collection. And that's the role of the type table. It was. Next slide. So let's talk about migration. Migration happens when you change things in your application, because you're not perfect, or at least I hope you're not, because it's boring, and your application is not either. It needs to evolve, it needs to change, it needs to be updated, and you need to migrate your data. How does it work? Well, it depends on a lot of factors. The first factor is the serializer. And if you're using Cryo, it is configured by default with compatible field serializer, and Kotlin serializations use CBOR, which is a format that allows for migration. And, well, you need to take that into account. You need also to take the type table into account. The type table allows you to move your classes from package and names. You can say to the type table, okay, this class has been renamed to this class, so if you encounter it from the database, then actually deserialize it with this other class, because this type don't exist anymore. But in essence, right now, it's a manual endeavor. It works. You can migrate your data. You are not locked into the data schema that you have defined at the start of your application endeavor, but it's manual, and of course, there's room for optimization there. We'll talk about that, but it works, and you can, of course, migrate your data. So, where can you find this database? At this address, github.com/coding-framework-coding-db. It is not binary distributed at the moment, because, you know, I made the mistake of wanting to release it for KotlinConf, and of course, I prepared this presentation instead of the release. So it will be released early 2020. There are 3 little things that need to happen first. API freeze, because writing this documentation, this presentation, I saw that there could be small improvements to the API. So thank you, KotlinConf. Then I need, of course, to write documentation, because which library, open source library, can work without documentation? And then I need to write some demonstration to ensure you that it works, because you shouldn't believe only my word. Once it's released, there's a lot of things that we want to add to this database, and we are actively looking for ways to support and finance the evolution of this database library. We want to add things like a proper migration API that we've just talked about, but of course we want to add coroutine support, especially now that multi-threaded coroutines are about to make their way into Kotlin native. We want to provide a compiler plugin so that you can roll back to easy annotations. We want to make it compatible with IndexedDB so that it can work in the web with JavaScript. We want to provide a cloud synchronization service. We want to offer data export and visualization tools. We want to provide full text search, and there's a lot of things that we could improve in this database. Thank you very much. Please do remember to vote on the application. And this is, once again, the link to the source code of the database. And if you have any question, I'll be happy to answer them. Looks like someone beat you to it.
Hi, I was just curious whether the indexing was part of the level DB layer or whether that was something that is done in Kotlin on the top of that.
So level DB is actually just a key value data storage. So no, it doesn't support index. It's something that's handled by the data layer in the layered architecture. In everything that I showed, level DB is responsible for data storage, which is a bit important, and then batch and snapshots are actually a feature of the level DB that we use, but they're handled by a level DB, and that's all. It's batch, snapshot, and storage, which are very important features, nonetheless.
Do you accept collaboration from outside developers?
Of course, the Kotlin DB is one of the libraries in the Kotlin framework, and we do have a history of accepting collaboration on all our libraries. So, of course, please make a PR, and we'll work from that. And most PR are eventually accepted. So, yes, absolutely, totally.
On Android, for now, we have a ROM database which can return flows as a result of queries. So if I have, for example, a person's table, person storage, I can do several queries like all women's, all men's, all persons who below 20 years old, and so on. And I will receive updates for each subset of items only. In your database, if I understand correct, I must register for each of these type of queries, did put, did update, and did delete, and so on.
Did put, there's no did delete. Put and delete, did put, there's no did update. Did put and update are actually just one operation.
Okay, did put and did delete.
Yeah.
But for each type of query, so it doesn't look like simple. It is going to be a lot of code. And does your coroutine support means that you will also add flows, possible to receive flows as a result?
So first of all, I did not show you every API. So of course, there's an API if you want to react on everything, and there's an API if you want to react on a subset of documents. So there's that. And coroutines and flow support are on the roadmap, but not on the first release. But it will be probably the first thing that will come after the release.
And could you please repeat the link to this presentation?
Oh. Here it is. And by the way, it's written entirely in Kotlin React. So the source code is available on GitHub.
Did you use some benchmarks in terms of performance, how quick it is?
So yes, I did. And I think there's room for improvement, but globally, in terms of write performance, LevelDB is extraordinarily fast. So it's very, very fast for write. For read, we're a bit slower than SQLite, but we remain in the same order of performance.
Regarding the subscription, what does it return? Like, what is it as an object? Is it like a normal observable, or like you showed the subscription slide?
Sure. So the subscription, I showed you a DSL, the subscription. So let's go back to the slide. No, it was. Okay. So this is actually a DSL. So this is the simplest way of writing writing a listener, but it's actually an interface with 6 methods, and you can implement this interface, and all methods have no-op default default body, so you can implement only the ones you want. Does that answer your question? So that's a DSL. So it will actually create an object of type coding DB listener, if my memory serves me. But that's just a DSL to create that object, that listener object. Okay, well, thank you everyone. Enjoy what's remaining of KotlinConf.
I'm Rodrigo Oliveira. I'm a principal software engineer at Gradle. And I've been developing the Gradle Kotlin DSL since the beginning. And I'm here today to share some of the things I learned during this process with you, right? Some of the tricks and tips that hopefully can save you some time in the future if you decide to explore this technology, right? And maybe, if I'm lucky, I can inspire you to build something really cool with this technology. And just before we start, I would like to clarify. So this is a talk about how you go about using this technology, the Kotlin scripting technology, right? To build something like the Gradle Kotlin DSL. This is not a talk specifically about the Gradle Kotlin DSL. I'll be glad to answer any questions, right, that you have. But this is about like how you use Kotlin scripting to your advantage to write your own scripting apps, okay? With that said, can I get just a show of hands of how many people use Gradle? Awesome, awesome. And how many of you are using Gradle with the Gradle Kotlin DSL? Great. And how many of you already use like build scans? Okay. So for those of you not using build scans today, I think the best Gradle advice I can give you is that you should run your builds whenever you have a problem, you are troubleshooting something, just run the build with --scan, and you get a lot of information from that, okay? That's the best Gradle debug tip I can give you to start with. Okay, so it was something like 3.5 years ago that Chris Beams, the original project lead of the Gradle script Kotlin project, as we call it at the time, right, revealed to the world what we've been working on, right? And it was like great reception, right? And at the same, in the same blog post, we could see what the very first milestone of the Gradle Kotlin DSL looked like, right? And okay, compared to the Groovy, counterpart of the same script, is a bit more verbose, and some things are not quite nice. But the IDE experience was there since the beginning, and that was great. That was like very promising, and that's why we persevered, right? And like even compared to what we have today, right? Like okay, but the thing is, we were able to get code completion, content assistance, refactorings, code navigation since the very beginning. That was really great, right? But we could only, have succeeded with the help of the Kotlin team, because like that was really early, in the lifetime of this technology. Like how early? Like if you check the date, that's the very first commit to the KEEP, the Kotlin Enhancement and Evolution Process, to the Kotlin scripting proposal, right? And that's 1 month after the first release of Gradle script Kotlin, right? So, like, things were really, like, wild, right? So, if you check the date for the first commit of the Gradle script Kotlin, or Gradle Kotlin DSL, as we call it today, right? That was even, like, 2 months even before there was even a KEEP, right? And it was really like the Wild West. Like, it was exciting for sure, but it was the Wild West, right? How wild, you might ask, right? Let's say we had to pay our dues, right? Like, that's how you would have to go to get the Kotlin compiler and the tooling to understand, that you want to enable some scripting application, right? And so I'm here to give you the good news, right? You are the lucky ones. And that's great, right? Now we have a new KEEP. And the API there, it's awesome. Like, it's partially implemented in 1.361. Not everything is there, but what's there is already like plenty, right? And 1.370 has much more like goodness in it, right? So what's a scripting application, right? What's the scripting about? For me, it's all about the experience. I know that's like kind of fuzzy, like new age kind of talk, right? But I hope that I can show you better than I can, maybe explain to you what I mean by that. And before we go into like the use case of something like the Gradle Kotlin DSL, which is maybe it's more complex and has more details, let's look at something simpler, right? Let's look at turtle graphics. Who knows anything about turtle graphics? Yeah. So turtle graphics is this idea, right, of like drawing like vector graphics by using like a cursor that is represented here by the turtle. And the turtle can actually like move forward, backward, right? It can rotate, right, left. You can put a pen down, pen up. You can choose the color. And people actually control this robot using this language, a programming language called Logo, right? Can you imagine like how fun that must have been, right? So the way you control that turtle, the way you do turtle graphics, right? You can issue a bunch of commands to this turtle, right? So I can tell the turtle to move forward. I can tell the turtle to rotate left, to rotate right, right? I can choose which color of, like which pen you should use to actually paint. I can put the pen up, right? So I can walk and not draw anything. But those are basically the primitives that you have, right? And the thing is, when you have to actually write like a turtle program, right? If you would write it like in the traditional way, like a traditional app, I'm going to write like a turtle program, right? So, sorry. So let's say I have my turtle graphics API, right? And I want to write, oh, sorry. How can I switch back to the app? Anyone else? No. Sorry, I'm just a programmer. That's all I can say. I know that's not an excuse.
You have to mirror your display. So you'd have to go into. No, it's not. So can I go out to the desktop?
Yeah.
Just put that down. Close that down also.
You want this?
Yeah, just to minimize it. So, it is here. Yeah, system preference.
Thank you.
So now you have
what
you see there is what you see.
Perfect. Thank you. Okay. So I have my turtle library, right? My turtle graphics library, and I want to write an app, right? A turtle program. So, okay, I'm gonna go like to the main, right? Because that's what we do in programs. You have like a main somewhere, right? Where you can write code and, okay, I see that I have a library here where I can do eval and write a turtle program. Luckily for us, right? Kotlin has this feature like implicit receivers and extension methods, right? Where we can actually inject some context into some function so I can have a sort of like a DSL, a domain-specific language for that function, right? So inside this function, I can then write stuff like, okay, I'm gonna, let's say, turn left 9 degrees, right? And then I'm gonna move forward by a certain distance. And maybe I'm gonna like, repeat that 4 times to get a nice, square. Yeah, but now I'm in this program, I have to maybe compile it, run it, right? So that's the experience we have when we write apps, right? You write an app and you run it, right? And then you can see the output, okay, I got my square there, awesome, right? But now I want to change this app, right? To change my program, I have to go back there. That's not nice, right? There's a lot of context around my Turtle program that is not related to my Turtle graphics, right? I have like this imports, I have other functions that I don't know what they're about, right? So this is not ideal if you just want to focus on the Turtle graphics stuff, right? So let's see what a different experience could be like, right? What if I have like just, you know, a blank sheet of, you know, of Turtle page, Turtle graphics page, right? Ready for me to write something, right? So now I can write, you know, my Turtle program, right? I can do the same thing. And now that I removed like all the clutter around, right? I can focus on my task. But also, now that I can have like this sort of like Turtle programs as separate documents, I can also like more easily, you know, compile, load, just that specific thing I'm working on. So I can do things more incrementally. For instance, I could have like a Turtle preview, right? Where I go and save and start seeing things, right? So I can go and do again, like repeat 4 times. Start seeing some stuff. Maybe I want the color to be like red, just because, right? Who doesn't like red? So then maybe I want to repeat the whole thing. Again, maybe. So I'm gonna do like 36 times. Oops, sorry. And I'm gonna like turn the turtle by 10 degrees, and then we start getting some stuff that's too small, right? But let's make this really big. Right, and I can play with it like very easily, right? I can have like almost like instant feedback of the things I'm doing, and that's what I mean by the experience, right? So that's what a scripting experience should be like, right? So now I'm gonna back to the slides. And I hope everything works. Nice. Yay, technology. So what's the scripting experience about, right? Is when you remove all the clutter, right, you can focus on the thing that you want to do, right? But you also remove a lot of overhead, computational overhead. Now you can actually have more of this instant feedback cycle, right? And that's really, really, really great. And the thing is, with the keep as it is today, it's very, very easy to do just this, right? So I'm gonna go through now the basic, like the 3 simple steps you have to do to get like the IntelliJ idea, to recognize your scripting application and provide the same level of like experience I just showed you, right? Like content assist, code completion, and all that, and navigation, sorry. So a Kotlin script, like application, a Kotlin scripting application, is defined first and foremost by a Kotlin script definition, okay? The Kotlin script definition is this class that becomes, by default, the base class of your script. You can imagine that your script is gonna be compiled, right, into a class. And that class will be like a subtype of your Kotlin script definition, right? In this case, we have like a turtle script that requires some turtle, like to issue commands to, right? And here we are using like this simple trick of using like Kotlin interface delegation, right? Like the turtle by turtle. So I can inject all the turtle names into my script. So now my subtype, right, can see all the methods of the turtle command. So that's how my script can see all the types. I can give a file extension, right, to my script. And the other very important piece of information is the third script compilation configuration, right? And that's the second thing you have to do. So the turtle script compilation configuration basically tells the compiler and the IDE what the dependencies are for this script. When you have a script, what jars you need to actually compile it, right? And you can actually tell the IDE, for instance, I want my users to store their scripts anywhere in the project hierarchy, or you can limit, the scripts to only be like at the project root level and other places like that. And you can inject interesting names, right, interesting types into the scripting context, like the color, so I don't have to actually remember that it's Java AWT color or type or have an import, right? So you can inject all the interesting names in there. And finally, the third piece of information you need to give the IDE, and that's the final thing, that's all you have to do, right? It's just this file with the name, right? This class name file is basically an empty file, it's like advertisement to the auto-discovery system that you have a script definition somewhere. And that's it, right? Just by doing that, you get all the goodness I just showed you. Isn't that amazing? Like, how cool is that? So then to actually execute the script, you just have to do a little bit more work, but that's basically what I'm showing you here. So you instantiate this JVM scripting host that is provided by Kotlin to you, and you ask this scripting host to evaluate a given script, a piece of source code, against the template, and that's it. So in this case, we also have another important piece, right, that goes with the eval call, which is the evaluation configuration, which must match, right, the compilation configuration. So I said my base type requires a constructor argument because it requires a turtle. So I have to give it a turtle here. And that's it. So now let's talk about like a more complex example. Like talking about Gradle would be maybe a bit overwhelming because there are many issues that we have to care about, and I want to focus on the Kotlin scripting experience. So let's see like a smaller version of Gradle that I'm calling like Gradler. So Gradler is like the Gradle toddler, right? I actually had to look it up, like Gradler, just to make sure, like, I'm not a native speaker, as you can probably guess. So you never know, you have to look it up in Urban Dictionary if that's some curse word or whatever, right? You never know. So I don't want to violate any code of conduct, which is great, by the way, to have one. So Gradle is a lot like Gradle, right? So the main interface, right, around the configuration of this tool is the project interface. So Gradle lets you define projects, and projects have tasks, right? And you can configure tasks, but projects can also have extensions, and these are like POJOs or rich objects that are contributed by plugins, right? By add-ons to your project to add interesting information to the project model, right? Tasks can perform some work, can depend on other tasks, right? So it's, if you know Gradle, you know what I mean. And action allows you to execute some configuration against an object. The important thing that I want you to notice, all these interfaces that I've just shown you are Java interfaces, right? And that's what add a bit of complication, right, to the whole mix. Because before, we had pure Kotlin code, and now we have Java. So we have to take some steps to make sure the experience is actually great as it should be, right? So we do basically the same thing that we did before, but let's first take a look at what we're expecting the experience to be, right? So we want to provide an editor to the user that allows the user to write something like this, right? So I can add plugins, right? I can declare plugins, so I'm declaring like a Kotlin plugin. And the Kotlin plugin actually contributed this Kotlin extension to the project model. So now I can actually just type Kotlin and configure the Kotlin extension, right? And I can define a task, and notice that when I configure the task, I'm actually getting like a receiver, like an implicit receiver in this block, in this lambda. So I can just say depends on. I don't have to say like something like give a name to the task variable or use it or something like that, right? And there's a catch here. We also want the experience to be like safe in the sense that it's statically typed, and safe in the sense that if a user didn't declare a plugin, didn't apply a plugin, or didn't declare that he or her is using the plugin, right? We want to make sure we get errors like this in the IDE, right? So if you have a plugin, it's all good. If you don't have a plugin, I want to have feedback, right? So we define our Kotlin script definition as before. This time, we have to take care of adding this thing that didn't belong to the original model, right? The plugins. So plugins is something that is coming from the DSL, from the scripting experience. So we just add this method plugins. So this allows the IDE to give code completion for plugins. We don't actually need an implementation, right? Because what we are going to do is we're going to inspect the script before we compile it to see if the plugins block is there, and we're going to handle it before the Kotlin compiler has a chance to do anything to it, right? And then we just define a nice interface so we can declare IDs, right? So we're using, again, like the implicit receiver there. Great feature. And, OK, so we give the IDE this definition, and this is the experience we get, right? We're getting there, but there are some things that are not quite nice, right? So the first thing that calls my attention is like this parameter name, like P0, right? This kind of like sticks out. So I want to take care of that first, right? So that's easy, right? We basically tell that the compiler we're using Java 8. We're going to use, the parameters. We're going to preserve the parameter names in the bytecode, and we tell the Kotlin compiler, right? We want the Kotlin compiler to actually consume, those Java parameters, right? And this is a Gradle Kotlin DSL script, right? If you've never seen one. So we're using the Gradle Kotlin DSL to create these other DSLs. OK, so now the experience is a bit better, right? Now we have this parameter name. But the other thing that sticks out to me there is that we have like this task, like this bang, like the platform type. So I don't want my users to bother with platform types, and I want like null safety, right? So that's easy enough, right? So there's the JSR 305, right? I think it's like annotations for something like defect detection or removal, right? So by doing something like this, right, creating that interface, that annotation definition there, and then declaring the annotation on the package, we tell, the Kotlin compiler basically that my API has no nulls, right? It's a non-null API. So if you see a string, it's a string. If you see a task, it's a stack. A task is not like a task, question mark. OK, getting there. So now we have like depends on and perform, right? They are in red. That means the compiler doesn't know what I mean. And we have this it there, right? As we used to call it, the dreaded it problem. So, oops. So that's a bit more involved. That's probably one of the features that I think we got the Kotlin team to implement specifically for our use case, which is great. Thank you very much. Big shout out to Ilya Chernikov. Thanks, man. So the main thing is, you can see your script definition, script compilation configuration right on the bottom left. And it has this configuration, right? Annotations for SAM with receivers. So you give that configuration the name of an annotation, right? And that annotation can live anywhere, right? It's your own annotation. So you don't even have to take a dependency on any Kotlin libraries if you don't want to or can't, right? In our case, we couldn't, because that was like Gradle core interfaces. So we needed to be able to tell the compiler from the outside, right? And then you have the annotation, and then you apply that annotation, right? And I made a mistake there, I'm sorry. So the SAM with receiver on the right should be on the action type. Okay, so where you're reading task, you should read action, and it should be the action interface. I just saw that now, I'm sorry. But once you have that, right, that's it, you get the experience now. Basically, action T becomes like T dot, parentheses, unit. So it's like a implicit function, or implicit function with an implicit receiver. Yeah, so now the last piece we need to solve, right, because we still lack some refinement to our script, is the extensions, right? So let's take some time and digest that. Don't worry. So this is inside the compilation configuration, right? I'm adding some stuff to my compilation configuration. I'm telling the Kotlin compiler that whenever, right, it needs to compile my code, right? Before compiling my code, I actually want to look at the code and refine the configuration. You can basically add more imports, you can add more stuff to the class path, right? You can change everything about the scripting configuration at that point. So what we do here, right, we just look at the script text, we see if there's a plugins block. If there's a plugins block, we go, we resolve, the plugins declaring that plugins block, however that happens, right? It's going to be, in the case of Gradle, right, we actually compile the plugins block as a separate script with its own, Kotlin script definition and its own configuration, its own environment, right? So we can provide a nice experience. And then after that, like the result of this process is a new class path, right? And the other thing we do, right, during this process, and we can do, right, is that we generate code. So we basically go, okay, so if you're going to use the Kotlin plugin, and then we apply the Kotlin plugin, and the Kotlin plugin actually contributed, extensions to this project model, we go and generate Kotlin code, like just a bit of properties and functions to let you statically access, right, those members so you can get a great experience. And then we, in this case here, in this like mini Gradle version, we also add a few default imports. So we assume all the extensions must be in this growler.extensions, right, namespace. And now that's how we can actually use, this new property and anything that the plugin contributes, right? And finally, we update the class path, right? So after we did that, right, we get the whole thing working. I rushed through a bit, I'm sorry, so maybe that was too short, but I'll be glad to answer any questions you have and help you with anything. Thank you.
So when you say you compile the plugins block separately, do you like run a compiler within the before compiling?
Yes.
Okay.
But in the case of Gradle, right, what we do is actually we have to go to the Gradle build. So Gradle has this this interface called TAPI, like the tooling API. That's basically a Gradle client that lets you run a build to get back some sort of like model answering the question, right? So during that refinement, we go and run a Gradle build, right? And you probably noticed that when you're using the Gradle Kotlin DSL in the IDE, right? We run the build to get the full class path, right? And generate code and do all that, and then we get the class path back, and all the imports, all that information comes from Gradle. Yeah.
Because I was wondering, when you do generate the extensions in Gradle, they have like the correct types, even though like they are actually defined in like the apply method of like plugins. So if a plugin says within the apply block of the plugin, apply method of the plugin, they pick up the extensions and add an extension with a type, you're able to pick up that type.
Yeah.
So I was wondering how that's.
Yeah. So right. So what we do there. So we have the plugins block, right? We compile it. So we compile it to this program that is basically applying the plugins to like a synthetic project, right? So, and then we introspect this project, right? And then everything is discarded. So it's only during that process. So for the whole, this is true what I said for like precompiled script plugins. For the usual project build scripts, it's actually, we run the full build, and then we introspect after the fact, because this script has been already saved by then, right? So we know the script has been saved. So we just delegate everything to Gradle. And then Gradle is just really configuring, running the whole configuration. We run it in a more like lenient way. So if there are like failures or like some other stuff happening, we try to just ignore the failures to get like the biggest, more useful class path we can to aid the user in the IDE, right? And that's when code generation happens. Of course, we have caching. So we make sure, for instance, all those plugins are contributing extensions to the project. From the project, we compute something we call like the project schema. And that project schema is basically like all the names and types of every extension we saw, right? It's more complicated because we also introspect like all the tasks, definitions, and we go like recursively into extensions because extensions themselves can be extended, right? So it's like this process of crawling the whole graph basically and coming up with this list of all the names and types and their owners, right? And then we use that schema as a sort of like cache key. So the whole schema is a cache key into this generated extensions jar that we have for each build. And that's how we can reuse. So next time, if you have the same set of plugins, right, you're going to get a new model, but it's basically like coming from the cache every time. Right?
So how are you finding this plugin block? Are you using some text search or actually using syntax tree?
Sorry, did I mention, I forgot to mention, so all this code, right, is available at github.com/bamboo/in-KotlinConf 2019, right? And there you find like a very amusing answer, or not, depending on your mood. But basically, in the mini version, right, we just use like text search, right? But for Gradle is a more robust version where we actually rely on the Kotlin lexer. We use the lexer to actually extract the block. So we use pieces of the compiler for that.
So if I make some alias to the plugin function, it is ordinary function. So for example, I can assign it to some variable, and from ordinary Kotlin, I should be able to code that. But in this case, it should break the Gradle build, yeah?
Well, so we have this rule that if you have a top level, so if it's a top level plugins block, we own it. You don't want it. You shouldn't do it, right? So that's the rule. But if you use like the plugins name anywhere else, right, it's okay, like as a variable name or you know, even as a function call, because we really just care about like this particularly, you know, invocation pattern where it's a plugins with a lambda, right? And that's it.
That's clear. Thank you.
Cool. More questions? No? Okay. Thank you very much, guys. Thank you.